and Aryabhatta.
Okay, nice.
The
I
Swiss
think it's a
application.
good. So this course started on which date, Suraj?
Yesterday. Yesterday.
Only yesterday. Okay.
Uh,
And to
uh,
last till
31st January. 31st January.
okay, it's a long course.
Yeah.
21
Yesterday,
days. Sir?
yeah, sir. Yesterday, Professor P.K. Joshi from JNU.
Right. He delivered. Okay.
Today, the other speaker is from, apart from you, we have got from Jamia Millia Islamia, Professor
Okay.
P.K. Pathak, Praveen Kumar Pathak.
Okay.
He'll be
Okay.
talking about projection.
Okay.
And in the second half, we have got all the laboratories related to
Yeah.
QGIS practicals.
Right. Right. So in the first half, you have designed your course in such a way that in the first half you will deliver theory, and then in the second half practicals.
Yes,
Is
sir.
it?
Yes.
Okay.
Yes, sir.
Yes.
And there is a minor project too that the students have to submit after 20 days. There's a format
Okay.
given by DST that each and every student means in a group, like if we have got 28 candidates, so we have to form 6 to 7 groups comprising
Right.
4 to 5 members, and
Hmm.
every group will submit a project at the end of this workshop.
Okay.
And the best presenter out of that 6 will be representing the what India in our next that UN Conference is there on geospatial technology in Hyderabad from 12 to
Okay.
14.
Great. So when is that conference?
सर
International
12 से 14 अक्टूबर है 12 to 14 October
October.
in
Right.
Hyderabad. So the best
Right.
selected, the coordinator will recommend the name. So to
Right.
whomever he will recommend the name, he will be participating. His entire group will move to Hyderabad. Each what fooding, lodging, accommodation, travel will be sanctioned by DST.
Right. So great.
So we'll be taking sir 1 or 2 minutes, and
Yeah.
thereafter
We can
I'll
start.
yeah,
Okay.
sir, I'll take
So
pass. After 3 or 4 minutes, you can
yeah.
start the program. Meanwhile, sir will also rely. Okay.
Yeah. No
Okay.
problem.
Okay, sir.
Okay. So uh, we can wait for 3 4 minutes. So right now I'm also keeping my video on. So during the lecture, if some bandwidth problem comes, I can switch off my video,
Yes.
or
Yes.
otherwise, what do you suggest here?
Sir, as per your choice, as per your
Okay.
choice,
No,
as per your
because many of the times your your actions and your so your the participants would like to see your face.
yeah,
So
sir.
that is why.
Sir, we
So
have
it,
got we
it
have got ample. No, no, Wi-Fi is not a problem for us. We have got
yeah.
sir ample bandwidth. The only sir,
So
so no issue, sir. You can on your
facial expressions are important actually to
yeah, sir,
get
sir,
the
very
feel of
important.
what you are going to teach or what
Yes,
you're going to tell. So in
yes,
that
sir.
case,
Yes,
facial
sir.
expressions are important. That's why in the class we, when we interact with students, so there they get that feel. So, so
Yes, sir.
something, some of the things you understand even from your actions and facial expressions.
Yes,
So
sir.
that is why I'm asking,
No,
should
no,
I
sir.
keep
No, no,
my
sir.
camera on or
Yes, sir. On, sir. On. It's our
right?
request. On.
No
तो सर अभी 1-2 मिनट पहला दिन है तो सबको थोड़ा बेनिफिट ऑफ डाउट दे दे रहे हैं 1 मिनट
problem.
मैक्सिमम मिनट और
Huh.
मैक्सिमम हाइट तो और नहीं है तो वी कैन स्टार्ट आफ्टर उपासना वी कैन स्टार्ट आफ्टर 1 मिनट
Okay, sir.
29s have joined Super, na, including me and you.
या उपासना प्लीज यू मे नाउ स्टार्ट द प्रोग्राम
Ritu is also there. Huh? Hello,
यस
Ritu.
सर
Ritu, how are you?
Yes, sir. Good morning.
So,
Uh, Namaste. How are you, sir?
namaste. I'm fine. Yeah. Switch on your video, Ritu. Can I
Yes, sir.
see you?
Yes, sir. Sure. 1 minute.
Good morning to all the respected dignitaries and the participants of the 21-day Winter Summer School in Geospatial Science and Technology Level 1 program sponsored by DST NGP. Today is the second day of the event, and without wasting any more minutes, let me introduce to our very first speaker of the event for day 2, Dr. Virendra Singh Rathore sir. Dr. Virendra Singh Rathore sir is currently working as an Assistant Professor, Department of Remote Sensing, Birla
I'm
Institute of...
associate professor.
Okay, sir. Sorry, sir. Sorry, very sorry. Associate Professor, Department of Remote Sensing, Birla Institute of Technology, Mesra, Ranchi, Jharkhand. He received his MSc in the science in the field of geology and Doctorate of Philosophy in Remote Sensing and GIS. His area of interest includes natural sciences, natural disaster, microwave remote sensing, hyperspectral remote sensing, surface water quality assessment and modeling, GNSS, and mineral exploration. He has more than 20 publications in various international and national journals. He is on the editorial and review board of various SCI journals such as African Journal of Environmental Science and Technology, International Journal of Earth System Sciences, Journal of Hydrology, Elsevier, and many more. He is a member of various scientific societies such as the Indian Society of Remote Sensing, Indian Society of Technical Education. Some of his major work projects are hybrid polar metric signature study under desertic environment under Reset UP, um, groundwater quality mapping under RGNDWM Phase 4 in various parts of MP, NUIS 1 is to 10K Bihar, National Wasteland Change Analysis Cycle 2015 to 16, and many more. So we are very delighted to have you here and would like to welcome you to start today's training session. Sir, please.
Okay, thank you, Upasna. So, Suraj, the topic is geodesy. So, I think your intention uh, of keeping this lecture in this training session is to introduce your participants about the use of GPS, or you can say it's a navigation system, GNSS, rather we can call it GNSS. Am I correct?
Yes, sir.
So intention is to give uh, means idea how can we use, what are the principles and the very important aspects of GNSS, right? So in that case, I can now I can tell you in this 2 hours of lecture about geodesy. the use of how geodesy is useful and how geodesy is important in case of GNSS, Global Navigation Satellite System, right? So, and in the next lecture, I think that is on 16th, I can include my talk, or I can focus my talk on total GNSS if, that is okay. Suraj, what do you think?
Agreed, sir. Agreed. Agreed.
So today it's with, should I limit with geodesy only?
Sir, it's up to you, sir. Your choice. Sir, your choice.
Okay, okay. Okay, I think a little bit of introduction of GNSS is important here, and then after I will come on the geodesy, and in the second lecture, that is on 16th, I can talk on DGPS and surveying techniques. That would be better, I think.
Yes, sir. Yes, sir.
Okay, so so now, instead of limiting myself today on geodesy only, I'll start with principles of positioning, right, in with the help of GNSS, satellite-based positioning system. So I'll be going that. So I'll be sharing firstly my slides, okay, and entire screen. We take it. Okay, okay. Screen is visible.
Yes, sir.
Okay, so probably slide is coming. So far slide is not seen to you, I think. Okay, let me off it. Can you see my slide?
Yes, sir.
Yes, sir.
Oh, okay, then it's
Slide.
good. I'll go to
Slide.
slideshow mode. I'll go to slideshow mode. Even. Okay, is it
Done, sir.
okay?
Okay. Yes, sir.
Yes,
Yes,
sir.
Okay,
sir.
so a little bit about the principles, right? And remaining thing I will cover on 16th, whatever is left, right?
Done, sir.
Okay, so uh, will not go in very basic things. Instead, I'll be telling you the communications part of the satellites, right? Directly, I'm coming over to the communication part. मैं एक
पीछे थोड़ा
लेक्चर ले रहा
समझ
हूँ
आ रहा
उसके
है,
बाद इधर इधर करवा मैं लेक्चर ले रहा हूँ ठीक है हाँ sorry I had some disturbance here okay so hello anything Suraj from your side
No, sir. Okay, sir. There was a noise. Now it's okay.
yeah
Now
yeah
there
in
was
the
a noise.
background somebody was asking something anyway so dear participants it's my pleasure to deliver this lecture in the winter school of DST, sponsored by DST, and I'm very happy to be invited here in this school. And thanks to Suraj and team that they have invited me here, and I'm feeling honored. So just there will be noise from the background because some coding is going on. Right? Just we can wait for. Sir, Suraj, so can you hear me or otherwise should I?
Sir, ठीक है आवाज ठीक है sir.
Yeah, I'm audible.
Yes, sir.
Okay. So at present, it's difficult. Just let's wait. It's
Sir, इससे पहले वाली जगह सही था.
whatever to hear actually. It's noise. There is a noise. Just wait. Logging is in progress. That is why I'm just.
ये पहले तो अलग से ही है। हेलो हेलो
Yeah. So now it has stopped.
हाँ
Hello,
हाँ
Suraj. So
हाँ अभी
now
सही है सर अभी सही है
okay. Right now it's okay, I think. So for your knowledge, I can tell you that right now in the space, couple of satellite-based positioning systems are operational. One system is Navistar GPS. Navistar GPS stands for Navigation Satellite with Time and Ranging. It is owned by US Government of Department of Defense, USA. So it was designed for the purpose of the defense initially by the US government, but later on this was opened for the civilian by seeing its usability applications for the civilian purpose. So around in 80s, in the early 80s, it was opened for the civil applications by the US government, right? And the first satellite was launched in something 1978, and the committee was constituted in 1972, and based on the recommendation of the committee, this was designed, Navistar GPS. And the other country which are having the satellite-based positioning system is Russia. So they have GLONASS, and the European Space Agency, they have Galileo, and the China is having Baidu. India is also having one satellite-based positioning system, that is IRNSS, Indian Regional Navigation Satellite System. It covers the the country, India, entire country, and 1500 kilometers from the border. So that is the area coverage of IRNSS. But I think the accuracy which we get from IRNS is not um, as good as from Vestar GPS we get, right? So these are the systems which are working at present. for giving us positioning. So presently, with the advanced GPS receivers, we can access the satellite signals of Navistar GPS and GLONASS, Russian satellites. And by that, we can achieve accuracy in positioning to the millimeter level, right? Positioning means, when I say positioning is defined by X and Y coordinates. I think you may be known. So I expect that you know what is the positioning. Otherwise, I will be telling you in geodesy part also, in subsequent slides. Just I am giving you introduction of the satellite systems, just right, and how they communicate, right? So, mostly we use Navistar GPS signals, and some advanced GPS receivers also receive signals from Russian GLONASS satellites, right? So when these two are coupled in advanced receivers, the accuracy is very high. As I said you, by differential GPS, we can get millimeter level of accuracy in positioning in X, Y, and Z. You can think of the level of accuracy. Means the position on the surface of the earth is defined by X, Y, Z. Okay, for any of the point, for any of the feature on the surface of the earth, how do we define? How do we say it is located here on the surface of the earth? So that is actually by X, Y, Z, right? Z is height here, and X, Y are coordinates. And in geography coordinate system also we have latitude and longitude. So these X and Y coordinates are Cartesian coordinates, right? So you may be knowing. Whenever if you think or if you have some question, you can interrupt me and ask. Okay. So I'll try to answer your question. You can, at any point, you can stop me and ask the question if you think so. Again, okay, now it has stopped. So I'll be telling you the satellite communication, Navistar GPS satellite communication here with this slide. Right? In this slide, you can see the fundamental frequency here. Then you can see the L1, L2, okay, and navigation message and the some structure like that. So what is it, right? So there is one fundamental frequency on which the atomic clocks work. This onboard satellite, there is atomic clock. So there is a difference in quartz clock and atomic clock, right? So whatever watches we are having are based on quartz oscillator. Whereas on board satellites, the watch or clock is not the quartz oscillator based. They are based on the elements that are cesium and rubidium. Okay, so from those elements, we get very precise timing. That is why they are known as atomic clocks, right? But those atomic clocks cannot be used in GPS receivers because of the cost and weight factor. Okay, so cost is very high. Such clocks may cost around 50 lakhs, and the weight is also very high of those clocks, maybe 25 kg, etc. So we cannot have then the GPS receivers portable, right? So to avoid the weight and the cost, in our GPS receivers we have quartz clocks, whereas on satellite on board the clocks are atomic clocks having cesium and rubidium oscillators, providing us highly very precise timing. Okay, so from GPS receivers we get X coordinate, Y coordinate, Z coordinates, and at the same time we also get atomic timing. So 4 components we get from GPS receivers, right? And with the help of all these 4 components, we can use GPS receivers in many applications. right? Many applications. So, so onboard clocks, the fundamental frequency is 10.23, means this is a very basic frequency. Basic frequency. That is why it is we call it fundamental. So this basic frequency 10.23 megahertz is there on board satellites. From this 10.23 megahertz you may be understanding million hertz. Okay, so number of cycles in 1 second. So 10.23 million cycles of the wave are generated, and this frequency is multiplied by 154 to get a frequency of 1575.42 megahertz, right? So one wave is generated of this frequency on board satellite. The another wave is generated of this satellite, this frequency 1227.60 megahertz. So these are two carrier waves. These are waves which are known as carrier waves, right? These two waves are transmitted from Navistar GPS. Navistar GPS is owned by government, US government, right? United States, right? So this Navistar GPS, you just keep in your mind that it is owned by US. Okay, and in this system, there are 24 satellites in 6 orbits, and 4 satellites are spared in again those orbits. They are moving at 20,200 kilometers above the surface of the Earth. Okay, each of the orbit is inclined at 55 degrees with the equatorial plane. Okay, so that is the design of the orbits of the satellites. This satellite speed is 11,500 kilometers per hour. With that speed, they can move or they can complete 2 orbits in a day of 24 hours, right? So that is the satellite part, and from those satellites, these signals are transmitted. What are these signals? 2 signals. One is L1, L2. These are 2 carrier waves, in fact, carrier waves, and these are actually of the micro, you can say, radio signals. What are these signals? These are radio signals. From the frequency, you can just understand what is the reason of electromagnetic spectrum, right? Electromagnetic spectrum. So these frequencies belong to radio region or microwave region also, because L1 is in microwave region, but it is in the last part of the microwave. So we also can call it the radio region. Radio waves are longer than this, in fact. So from remote sensing point of view, you can say these are microwave signals, but in GPS we call it radio signals. So having radio signals transmission gives us advantage, because the radio signals have capability of transmitting through clouds. So in all weather conditions, we can get the signals. Okay, so positioning is possible in all weather conditions from this satellite-based positioning system because of the radio signals. So one frequency is 1575.42 megahertz, and another is 1227.60 megahertz, transmitted from the Navistar satellites. 24 satellites are there, as I told you, right? So at any of the times, we can get signals of minimum 4 satellites. Okay, and minimum 4 satellites are required to get the 3-dimensional positioning on the surface of the Earth, right? So in other words, you can say, to get the 3-dimensional positioning on the surface of the Earth, we need to have signals of minimum 4 satellites, right? Okay, is it clear up to this? Any doubt? So now, in the next part, on these signals, we have some codes. Just see here, CA code and P codes are mentioned. Okay, CA code and P codes. So CA code is modulated on this signal at the rate of 1.023 megahertz, and P code is modulated on the signal at the rate of 10.23 megahertz, that is equal to the fundamental frequency, basic frequency. So here you see, just if the fundamental frequency is divided by 10, we get the frequency of CA code, and when it is not divided or by multiplied, then same frequency code is again we are generated, sorry, are generated, and these codes are modulated on the L1 carrier valves. Modulation means they are encrypted on the valve. Okay, so in the code form they are encrypted. So what is this code? This code is nothing but time information of relay of the signal. When signal is relayed or generated to come to the surface of the earth, right? At that time, the what is the time recorded by the atomic clock is encrypted on the signal in the form of code, and these codes are binary codes. Binary codes means 0 1 1 0 1, a computer language. So whenever we receive these code, your microprocessor of GPS receivers can decode these codes. Okay, means the value is obtained by decoding this code. What is the value that can be obtained, right? So 0 1 1. So in the computer, whatever value we get, say 1 lakh or 10,000, 5,000, 100, 125, all these values are written in the form of codes. So these codes are nothing but time information of the relay of the signal, okay, that is communicated in the form of codes, encrypted codes on the L1 signal. Is it okay? Okay, then the another wave is generated of this frequency. So there is a difference in these two frequencies, the C1575. So this is higher frequency, this is slightly lower frequency, 1227.60 megahertz. On this lower frequency signal, no CA code is available, only P code is modulated. Okay, so there is a reason of not having CA code here. Okay, some of the times, or maybe it's wartime or some to deny the hostile forces access of highly accurate positioning, they generally block the P code. Okay, intentionally they introduce the error by blocking the P code, or but the US Army can access P code. So this P code is written as Y code during the wartime, or maybe if they want to deny to some hostile forces. So in that case, they can modulate P code as Y code, right? Not P code. So many of the manufacturers don't know how to decode the Y code, so they don't get access of P code, and at that time the positioning accuracy is dependent only on CA code, and that is lower than the P code. Okay, so a degraded positioning is possible only if they deny the P code. Okay, that is why here they don't have CA code, they have only P code. Okay, so that much is enough for you, I think, here. So CA code and P codes are nothing but time information. So CA code is at lower frequency 1.023, that is why the positioning accuracy is lower here. And if we can access P code, which is modulated at 10.23 megahertz, and in this case positioning accuracy will improve 10 times than the CA code, because frequency of getting information is higher here, right? So this is the part of signal. Then they also transmit navigation message at 50 bytes per second. Along with these two these two signals, they also transmit another message, that is navigation message, and it contains the satellite position in the orbit, predicted satellite position in the orbit, atmospheric corrections, and satellite health, right? that is communicated through this navigation message. So in altogether, a GPS receiver receive these information and navigation message, right? So that navigation message is also helpful in calculating the positioning. Okay, and here also you can see in this diagram the structure of the signals. Here you see the L1 signal, how it looks like, and the code, CA code, okay, structure of the CA code, and then the P code, right? Okay, and it is actually block diagram. Okay, in the microprocessor there is one mixer. Okay, and in that mixer two types of signals are mixed, and then they are correlated to obtain the information. Okay, so this part is clear to all of you. Any query here? Can I move? Okay, then there is no problem. And this information I don't think, don't know it's important or not. In this slide, I am just giving you the types of, about the types of receivers. There are three types of receivers available in the market. One is CA code based. Here we get lower accuracy, 1 to 3 meter of positioning accuracy, and positioning is based on only on CA code. And these are only navigational type of receivers. Then we can have GIS mapping type of receivers. From those receivers, we can get 10 to 30 centimeter level of positioning accuracy. Okay, and here the cost increases of the GPS receivers. It may go up to, it may be around 5 to 10 lakhs. Okay, demerit is that to achieve high accuracy, we need to give substantial occupation time. And then third types of GPS receiver which is available in the market is survey grade or dual frequency receivers. From this type of receivers, we can achieve millimeter level of accuracy by performing DGPS surveying techniques, right? So we'll be discussing probably in the next class what is DGPS. Okay, here I have just included the pictures of satellites. Block 1 satellite look like this. The block 2 satellites, the design is different, and this was built by Rockwell. These are all Navistar GPS satellites, and I'll be telling it later. Okay, let's keep this. Just see. Okay. Yeah. Okay. In this slide, what you see, there are two types of codes. One code is receiver generated, and another code is satellite generated. Right? How do we get positioning with the help of GPS receivers? So that part is explained here. Okay, I'll try to tell you here. How do we get positioning? How do we calculate X, Y, and Z? Right? How, or you can say in other words, how GPS receiver provides you X, Y, Z. Okay, directly when you are using GPS receivers, you get positioning. Okay, but you don't know what is happening in the background, right? So in the background, what is happening? A GPS receiver, as soon as a GPS receiver receives a signal from satellite, okay, as soon as a GPS receiver receives signal from the satellite, what happens in the microprocessor of the GPS receivers? Microprocessor of GPS receivers generates similar code. As I told you that in the satellite signals, we have CA code and P codes. Okay, I told you that from the satellite signal or on the satellite signals, we have CA code and P codes. Okay, CA code is modulated at 1.023 megahertz rate, and P code is modulated at 10.23 megahertz rate. Right? Then this information is there on the satellite signal, and receiver receives these signals. As soon as a receiver receives the signal, the receiver itself generates a signal code which is very similar to the code in the signal. Okay, so here, look here, the code generated by the satellite, and the below code is generated by the receiver. Okay, these two codes are very similar in structure. Okay, for example, CA code. Okay, so similar CA code is generated here in the receiver. But what is happening, because this code was generated earlier at the satellite, and this code was generated, the lower code was generated later in the receiver. Both the code will not match, okay, because it was generated later. You can just understand from the example. You are suppose 25 years old and I am 50 years old. We don't match together, right? My thoughts will not match with you because I am 50 years old. I have so many things in my mind, and you may be different from me. So we don't match because there is an age gap. Okay. So in that case, if you go back to, say, you are 25 years of age, if you go back yourself, you take yourself back to 25 years from present, your thought and my thought will match, isn't it? Now you're also 50 years old, suppose. Okay, you have to go to 25 years back, then only my thought and your thought and my frequency and your frequency will match. The same thing happened here. This upper code was generated microseconds back, and this was generated microseconds later. So both the codes have some not matching. The structure is similar, but they are not matching. So what is done here in the microprocessor? This code, the receiver generated code, is pushed backward until both the codes matches. At one stage, both the codes will match. So how much this code has been pushed backward, that value is obtained, and that value is multiplied by the speed of the signal. And the speed of the signal is 3 into 10 to the power 8 meter per second. So what do we get from this information? We get satellite distance from receivers, right? Is it clear to all of you? Just see here this code, some value is written here. If this code is receiver generated, and we also have one more code like this, that is the satellite generated, in that also we have this value, but these codes are not matching because it was generated later. So this code has been shifted backwards until both the codes matches. So some value we get by pushing it backward, that value is equal to the travel time of the signal from satellite to receiver, and that travel time is multiplied by the speed of the light, and that is the speed of the signal, 3 into 10 to the power 8 meter per second, and by multiplying the delta t by the speed of light or by the speed of signals, we get the distance of satellite from receiver. Is it okay? Is it okay? Did you get?
Yes,
I'm
sir.
not getting any answer. Or
Anji sir,
Yes, sir, it's
we are,
okay.
it's
we are
okay.
Yes,
getting it.
sir.
Yes, sir.
Okay.
Yes, sir.
Okay.
Yes, sir.
So when we get
Sir.
distance, just see here also in this slide how the codes are matched. Okay. Just examples, the matching code matching process, correlation, and other people say correlation. No correlation here, but here is partial correlation and is a full correlation. Both the codes are matched, right? So for how many digit has been pushed backward, that value is the delta t. Delta t is nothing but travel time of the signal from satellite to the receiver. Okay. So this is block diagram of the receiver. So here is one antenna. In the antenna, the signals are received. Then there is a pre-amplifier that amplifies the signals because signals are low powered, so amplification is required. Then in the mixer, two codes are mixed, then correlation is done, and then the delta t is obtained. Then finally the travel time is calculated, and the distance of the satellite is calculated. Just see here in this slide. These are satellites. Okay, 1, 2, 3, 4. Minimum 4 satellites are required. So now this distance of the satellite is calculated with the codes or with the phase. There are two ways of calculating the distance of the satellite. One is the code based, that is known as pseudo random noise, pseudo range measurement, because these codes are known as pseudo random noise codes. The satellite distance based on pseudo random noise code is known as pseudo range measurement, and satellite distance calculated with the help of phase difference, that is known as carrier phase measurement. So there are two ways of measuring the distance of the satellite. One is the pseudo range measurement, another one is phase difference, carrier phase difference measurement. Okay. So satellite's distance is crucial here, vital. Satellite distance is very vital in getting the XYZ of this point. Right? This is a receiver. And of the receiver, we are interested to know the X, Y, and Z. And as I told you, minimum 4 satellites are needed. Right? So distance of the satellite is calculated. Now you see, we have calculated the distance of the satellite either from the codes or maybe from the phase difference. Okay. Suppose in calculating the distance of the satellite, some error is there, then what will happen? There will be error in positioning. As the positioning of the receiver is totally depend on the calculation of the distance of the satellite. Okay, so 4 satellites. Okay, so receiver calculated the distance of this satellite, calculated the distance of this satellite, calculated the distance of this satellite and this satellite. Now you see, imagine there is a one satellite only in this space. Then what happens? Say this blue circle. Can you see this blue circle? Right? So from this satellite, this is the distance of the receiver. Okay. And if a circle of radius equal to this distance is constructed around the satellite like this. Okay. Around the satellite like this. So this is circle of the radius equal to this distance from satellite to receiver. So where is the receiver? Receiver is on the circle. Are you getting my point? Where is the receiver? Receiver is on the blue circle. Why it is on the blue circle? Because distance of the receiver is equal to the radius of the circle. Okay. So what is the radius of the circle? Radius of the circle is the distance from satellite to receiver. Radius of the circle is equal to the distance from satellite to receiver. That is why the receiver is on the circle, isn't it? Okay. So in the space, if we have one satellite, we don't know where is the receiver because it can be only anywhere. We have only information that receiver is on the circle. Okay, that is information only we are having. So, but we don't know in which direction it is on the circle. Direction is not known here. Only information which we are having is that the receiver is on the circle. Okay, if we have only one satellite in this space. Then if we have two satellites in this space, then see the intersection of the two circles. What is the intersection of the circle? See another circle, that is a red circle. Okay, red circle. So receiver is also on the red circle, but we have two intersections. One is here and another one is here from these two circles. So we still don't know where is the receiver. Either it is here or here. That is why we need the third satellites. From third satellite, we'll get a common intersection of three satellites here. So that would be the location of the receiver in the space. Yeah, we can see receiver is here at the intersection of three satellite circles. So as we get more number of satellites, this location becomes precise and precise. That is why if the more satellites are available in the space, the position is accurate, more accurate. Okay. So it is directly related to the number of positioning accuracy is directly related to number of satellites available in the space at the time of positioning or observation. Okay, so probably you have understood this concept of positioning. Again, in the diagram, I have shown the satellites, and here again you see. So this the line. These are line because of suppose we have some error in measuring the distance of the satellite from receiver. If this is the error, then there will be this much of positioning error. Okay. Location will change of the receiver if there is error in the range measurement. Okay. So with this diagram again, you can also understand the location, two satellites, the two circles, and this is receiver, but here is also intersection. We don't know where is the receiver. Okay. So this is
Excuse
because
me,
of
sir.
error. Yes.
Excuse me, sir.
Yeah. Please ask.
Sir, my name is Dr. Vikram Ranga.
Yeah.
I'm a postdoctorate here at JNU. I
Okay.
take lot of this. I do lot of field survey, sir, and I
Yeah.
use lot of GPS and DGPS. Sir, my
Yeah.
question is this, sir.
Yes.
Actually, I wanted to compare the handheld GPS and DGPS, the readings of
Mm-hmm.
both of them. Now,
Yeah.
when I went to the field with my mobile phone, I
Mm-hmm.
normally use GPS Essentials. So
Mm-hmm.
the number of satellites I receive is always over 20.
20. So it means you are
Yes, sir.
receiving GLONASS and Navistar both.
Yeah, that might be, sir. That might be. So
Right.
the accuracy is very, very good, sir. Very, very good.
Okay.
I mean, I have not compared it theoretically, but it's very good, sir. The
Mm-hmm.
DGPS and the GPS are all very good. My question is this, sir. Theoretically,
Mm-hmm.
sir, I'm asking,
Mm-hmm.
will it be worthwhile to compare and contrast the our handheld GPS systems, for example, my Android phone,
Mm-hmm.
with that of DGPS? Because
Yes.
DGPS is very expensive, sir, and I know many of the researchers, they do not have the facility of DGPS. So,
Mm-hmm.
do you think it will be worthwhile to compare and
Hello.
contrast
I can.
and make a study out of it?
Yeah, it is. It will be worthwhile to compare. It is very much important. Comparison is very much important because from handheld we don't get the level of accuracy we get from DGPS. The reason is that number one, when you will carrying a GPS, mobile phone or handheld GPS receiver, number one, your hand will be shaking, okay, all the times. So because of shaking, there will be error, number one. Number two, your mobile phone GPS receiver, the GPS in mobile phone and handheld GPS are mainly based on CA codes. Positioning is based on CA code. So from CA code, we don't get centimeter level of accuracy. We get always in meters level of accuracy, right? That is one point because they are low cost. So they don't provide you the facility of accessing P code in the software, right? So when you are not able to get P code, you don't get high accuracy, definitely, right? and so many errors because of atmospheric corrections, ionospheric as well as tropospheric errors. The positioning accuracy will be degraded. It will be in meters only. We don't get millimeter or centimeter level of accuracy from the receivers enabled in your phones and in your handheld GPS receivers. Okay, and so many errors are also there. I will be discussing the
Yes, sir.
error part.
Thank you very much for this, for
So
clearing
comparison
this.
is definitely worthwhile. Whenever you
Yeah.
carry out the, it depends upon your requirement actually. What kind of requirement of your project of accuracy, positioning accuracy, right? Suppose in some of the projects, accuracy of meter level is enough. In some of the projects, accuracy of millimeter level is required. So if your accuracy of millimeter level is required, in that case you use DGPS only. That is my recommendation, right?
Okay. Okay, sir. Just one more question, follow-up question,
Yeah,
if you have time, sir.
yeah.
I'm
No
sorry,
problem.
because we do not get opportunity talking to people like you. Um, Sir, I have a single antenna DGPS,
Yeah.
and my study area is very flat. It's in the marginal Gangetic plains.
Okay.
It's basically the Chambal Valley I map normally.
Okay.
So, do you think it's good enough for a single antenna DGPS that I go and do this kind of mapping? Because
Single antenna DGPS is okay, but it will take more time to achieve the high accuracy because it is single. So multi-channel antennas provide you fast to reach to higher level of accuracy. So it is fast and it is slow. That is one point. And
okay,
sometimes
sir.
it may also depends that you are not achieving the highest accuracy, that is millimeter level. It may happen. Which is the GPS receiver you are having?
Sir, we have this Sokia.
Sokia. Okay, it's a DGPS.
Sokia DGPS, sir. I don't remember the make of it, the model number of it,
No,
but
no problem.
Sokia is the company, and it's
Okay,
single frequency.
it is so we don't get that millimeter level of. It is difficult to achieve millimeter level of accuracy, but sometimes you may get.
Okay.
But I
Okay.
think it is not providing you millimeter level of accuracy. We are having Leica, advanced Leica at this time, and from that we can get millimeter level of accuracy in very short time of observation. So that is advantage and disadvantage of
Yeah, sir.
advanced
They
systems.
are very very expensive and
Yeah,
some.
yeah, very expensive. But what is your project? It depends on your requirement. If you don't have a requirement of high accuracy, millimeter level, because millimeter level of accuracy is required when you want to establish a control points or you want to measure the tectonic movements, okay, or deformation activities, any deformation, subsidence, and kind of things, then it is this millimeter level of accuracy is required. Otherwise, in centimeters, mapping kind of work is no problem.
Sir,
In GIS mapping kind of project, you
yeah.
don't have any problem.
Sir, in our project, we are trying to map the topographic differences, that means elevation differences of
Oh,
dead river, paleo courses. So there is a lot of vertical accretion.
uh,
So we actually do not know how much deposition has occurred in them.
huh,
So we were thinking, we did some work with it, sir.
yeah,
But we hired someone and we took multiple frequency DGPS, but
uh-huh,
that is not with us, and
okay.
we only have Sokia single
Mm-hmm.
frequency. So now, if you want to map more of it, then we have to go with single frequency. So that is why
Yeah,
I was
yeah,
asking.
yeah. Minor differences. In minor differences, may be some problem. You may have problem. Suppose your deposition is in the tune of some centimeters, then it may have some problem. You don't get uh, difference. What is the accretion or what is the positions taking place in centimeter or not. If it is significant, then there is no problem. But if it is insignificant, if it is in centimeters only, then you may have problems. Because in Z,
Okay.
accuracy is always lower than X and Y. In
Yes,
Z
yes.
direction,
Actually,
accuracy.
we do not know. Nobody has mapped them before, so
Yeah.
that is why we wanted to go for the maximum accuracy.
Yes.
And I
Yeah.
mean, we are going to be the first one to report them, so that's why
Yeah.
we were just concerned about the accuracy.
Yeah. You can sometime check with differential GPS of high advanced level of GPS receives. You collaborate with someone, and I think your problem will be resolved, addressed.
Okay, okay,
Okay.
okay, sir.
So
Okay, sir.
Like
Thank you very much.
yeah.
Dr. I will like to add that Professor V.S. Rathore sir has got a specialization and a lot of publications in paleo channels. He has got his PhD in paleo channels in Saraswati River. So you may contact him, and he's the appropriate person who will be guiding you a lot of knowledge related to whatever questionnaire you had.
Sir, thank you, Professor Singh. Actually, I know about her, and that's why I said that we do not get opportunities like this one which you have provided.
Anyway,
That's why I was
we'll
asking
later
questions.
on we can talk on it. You
Yes,
can
sure, sir. Thank
okay.
you very much, sir. Okay, sir.
Contact. Right. So so here also you can see if two satellites are there only, even then we don't know where is the receiver, because two intersection we are getting here. And this diagram showing you the error, how by the wrong range measurement the errors, the positioning shifted. See here, in case of red and in case of yellow, the receiver positioning has shifted because of the error in the range measurement, right? And this is the example of three satellites. So we can get the location of the receiver if we have three satellites available, but it is two-dimensional, and for four-dimensional we need to have, three-dimensional we need to have four satellites. So this is again because of errors, shifting of locations of receiver. In this direction, it can go to in this direction, like that. This is the true positioning. And here I have just included one slide for telling you about the errors in range measurement. When we measure the range of the satellites, error can be because of ephemeris and clock stability, ionospheric delays, tropospheric delays, multipath, satellite and receiver clock errors, receiver noise, selective availability, and entity spoofing. And I don't know, do we have time to go in details of these errors? Just let me see, because I have to cover the geodesy part also. So it is
No, sir,
10:59,
we can
right?
move on, sir. We can move on with
I can
overall.
skip. Can I skip this part,
Yeah.
or
Only the
should I touch?
say
Sure, a little bit touch only. Okay. So in range measurement, the one error source is ephemeris. What is ephemeris? Ephemeris is satellite position in the orbit, right? Satellite position in the orbit. Satellites moving in the orbit. So at the time of observation, what is the satellite position? That is important. So if there is something wrong in the ephemeris, satellite position, our accuracy will be, affected. So ephemeris, just understand this is one satellite, and it's there will be two kind of positioning of the satellite. One is the actual positioning of the satellite that is recorded at the control master control station of the satellites, right? So control segment, there is one control segment that records, observe the movement of the satellite all the times from the monitoring stations, right? So what is the actual position of the satellite in the orbit at the time of the observation is recorded at the control station. Then based on the actual position of the satellite recorded in past 7 days, they model the satellite position in the orbit for next 24 hours. So predicted, modeled, and that is communicated to the satellite from the control segment, and that is communicated to the receiver's part, right? So what we get is modeled ephemeris. We don't get the actual ephemeris. Actual ephemeris is with the control segment. Okay, satellite position. So satellite position may be different from the predicted position of the satellite in the orbit because of the atmospheric drags, right? So at the time of observation, the satellite position or ephemeris that is communicated in the navigation message to the receiver may be different from the actual position. So this can be one source of error in the positioning, right? Then this clock stability is the atomic clock and the receiver quartz clock, and that has been overcome. So this error does not exist. This is actually the difference in the atomic clock timing and the quartz clock timing that is in the receivers. But this has been overcome by solving the equations, right? Some sort of calculation, solve this difference, and then we get the atomic timing here also in the receivers, right? So this has been, it does not exist. So don't worry about clock stability timing error. Then is ionospheric delay. You know, in ionosphere, what happens? So ionosphere consists of electrons. Okay, so electron density vary with time to time and latitude to latitude and season, and it also depends upon sun to earth distance, right? Ionosphere electron density depends upon the latitude, the time of the day, the season, and the distance between sun and earth, right? Now what happens here, when signals travel from outer space through the ionosphere, what happens, a refraction will take place and the signal also slows down, so some kind of delay happens here. Okay, so when delay happens here and we are multiplying with the time to get the range of the satellite, definitely there will be error. Okay, so during the noon time there will be more high electron density in the ionosphere, so delay will be more. In the equatorial region, because sun rays are direct, so electron activities will be more in the ionosphere and we get more delay here. As we move towards the higher latitudes, the sun rays are inclined and we get less ionospheric delay in the higher latitudes than the equatorial region. Okay, so during the night and during the morning or during the evening, ionospheric delay will be less. So it also depends, your accuracy also depends on the time of the observation. Okay, so those who are working with GPS also can, you know, set their timing at what time they will get the high accuracy, right? So ionosphere will be minimum during the morning hours or even in the night and evening times. And tropospheric delay is something related to the aerosol and moisture content in the troposphere, right? So if the moisture contents are high and aerosol is more, the refraction will be more here of the signals and delay will be more. Then the multipath, some of the nearby of your working area, you may experience, sometime you may have the surfaces which can reflect the signals. Okay, so indirect signal we are getting. First, signals are interacting with the surfaces which can reflect the signals, and then signal reach to the receivers. So multipath effect comes here. Suppose some big antenna is there, some water body is also nearby you, and some glass panel is also suppose are there. In that case, the signals are first interacting with these surfaces and reflected signals are reached to the receiver. So from the reflected signals, we get delay, and then this type of error is known as multipath, and we get lower accuracy again. So you can avoid if such surfaces are there, or you can have advanced antenna. So those antennas actually reject the signals which are coming from the low angle. Okay, ring choke antenna and then hemispherical antenna rejects the signals coming from low angle. Okay, so accuracy is also dependent upon this. Okay, satellite and receiver clock errors. Sometimes there can be mechanical error in the clocks. Receiver noise depends upon receiver quality, definitely. Selective availability is the intentional error. Anti-spoofing is the intentional error. Selective availability is the actually what happens. The satellite clock is shifted slightly, but intentionally by the control segment of Navistar GPS. So that process is known as dethering. So what is dethering? Dethering is slightly satellite clock timing is shifted. Okay, if and that difference of timing is known to the US Army, but not we don't know. So this is introduced only during the war or some intentional. Otherwise, it does not exist. And anti-spoofing is something that is in that case P codes are modulated as Y code. So these are the intentional errors in GPS, but they don't exist at present. Lifted in May 2000 by the order of US President. These two errors. So these two errors don't exist, and there may be receiver noise, depends upon the quality of the noise, and this can also be there. Multipath can be there, tropospheric will be there, ionospheric will be there. This does not exist, and ephemery and orbit perturbation will be there. So these errors can be eliminated while working with DGPS. Okay. That is why we get in millimeter. Otherwise, if we are having only single-handed receiver, these errors will be there, and our positioning accuracy will be in meters only, not more than 3 meters. That is my experience. From my experience, I can say with the single-handed receiver and the GPS in mobile phones, we don't get accuracy better than 3 meter, positioning accuracy better than 3 meter. Hardly we can reach to 1 meter, and that is I have not seen. Okay, and I'll not touch this part. And this is another source of error. How satellites are distributed in the sky at the time of observation. Just see, if the satellites are closely spaced like this, the positioning accuracy will be lower, and if satellites are well distributed in the sky, the positioning accuracy will be good. So you can also consider this satellite geometry at the time of observation, at the time of surveying, right? Also see how the satellites are distributed in the sky. This facility is given in receivers. Okay, so in the receiver also see, when you start observing a point, how is the satellite geometry in the sky at the time, right? So that is actually DOP, dilution of precision. Okay, so in your receiver you will get information at the time of observation. What is the PDOP, SDOP? PDOP should be less than 3 and GDOP should be less than 6. So that can be little reliable, but accuracy will be higher if this is smaller. Okay, PDOP, GDOP is smaller, then accuracy is higher. Okay, so it is inverse. Now the geodesy part, topic of today's lecture. Just wait for 1 minute. Okay. So what is geodesy? Geodesy is a branch of science which deals with the shape of the earth, size of the earth, defining coordinate system on the earth, the direction and positioning, okay, on the earth. So geodesy deals with many things like size, shape of the earth, precise positioning, elevation point, length, direction of lines, terrestrial gravity and its variation. Okay, and GPS is latest inclusion in the geodesy, right? So GPS is also now has become part of geodesy. That is the geodesy, right? So what is the figure of the earth? Figure of the earth has various meaning in geodesy. In the beginning, we thought of earth as flat. We thought that earth is flat, okay? And for a smaller area, it is acceptable in surveying. For 10-kilometer area, 10 square kilometer area, flat earth concept can be accepted. But if the area is bigger, large, then the flat earth concept is not applicable because effect of curvature will come in the measurements, right? Then the people started thinking that earth is not flat, it is spherical, okay? But it can exactly does not model exactly the earth. So shape of the earth is like an ellipsoid, but so as mentioned here, it fails to model the actual shape of the earth since the earth is slightly flattened at the poles and bulges in the equatorial region. Do you agree? Do you agree?
Yes, sir.
Yes, yes,
Yes,
sir.
sir.
So,
Yes, sir.
Yes,
so
sir.
earth
Yes,
is
sir.
not
Yes,
spherical,
sir.
earth is not flat, earth is not circular, earth is like an ellipsoid, isn't it? Ellipsoid means the radius in the equatorial region and in the polar region is different, right?
Yes, sir.
Okay, so an ellipsoid of revolution actually model the shape of the earth. Ellipsoid of revolution model the shape of the earth. Okay, so see here, I have shown you, I'm trying here to show you the surface of the earth, the another blue line that is geoid surface, then dotted line that is an ellipsoid, right? So this part is also very important in GPS and GNSS. Presently we call it GNSS, Global Navigation Satellite System. So it has become now GNSS because we also get positioning from GLONASS, we get positioning from IRNSS, people get positioning from Baidu, right? People get positioning from the Galileo. So now it is not GPS only, it has become GNSS, Global Navigation Satellite System, right? So I'm trying to show you here three surfaces. One, two, three surfaces. Just see. One is this green line is representing the surface of the earth. Okay. And this surface of the earth, how it appears, how it looks, it is undulating. Okay, irregular. Are you agree? It is irregular. The second surface, which is blue line, geoid surface, is also undulating. But this dotted line is smooth. It is not undulating. Okay. So these three surfaces, just see the relationship between these three surfaces. Surface of the earth, the geoid surface, and the dotted line, red line. ellipsoidal surface, right? So why I am showing you here, because in GPS you will come across the ellipsoid. Okay, you will come across WGS 84. Am I correct? Ellipsoid. You will come across ellipsoid. That is why here it is very important. Why ellipsoid? Why surface of the earth I am showing you? Why geoid surface I am showing you? So just understand these surfaces. Surface of the earth. Okay, it is irregular. Okay, it is not smooth. It is also dynamic. You may be knowing. Okay, today this line is like this. After few years, this may not be like this, because on the surface of the earth, natural agencies like water, wind are acting. So they will change the surface, and even anthropogenic activities are also there. So they will change the surface. So can we take this surface as reference? No, we cannot take this surface as reference, isn't it? You agree? Suppose I want to measure the height of this point. Can I take this point as reference? No, I cannot take this point as reference, because after few years, I'm not sure this is not going to change. This will change, isn't it? This may change because of action of water, because of action of wind, because of action of glacier, because of anthropogenic activity. So I cannot take this point as reference to measure the height of this point, isn't it? So in overall, what I want to say here is that we cannot take the surface of the earth as a reference surface. Okay. Then can we take this geoid surface as reference surface? No, we cannot also take this surface as reference surface, because this is also changing. This surface, geoid surface, is the equigravity potential surface of the earth. What is the geoidal surface? The geoidal surface is
Equipotential surface.
Yes. So it is, defined by the gravity force of the earth, and it is represented by the sea surface. You go to the sea surface, it is highly rough. All the time it is fluctuating. So we cannot take it as a reference surface in satellite-based positioning system. Now in our topographic maps, we have height from mean sea level, and that mean sea level is also obtained from the geoidal surface. But it is averaged after 19 years of hourly data, okay, at few points, and then average is the 0, and that is the mean sea level, and from that rest of the levels are measured on the surface of the earth. Okay, so here it has been used, but mean of this is taken. But in case of satellite based positioning system, we cannot get the mean. We don't have time to get the mean, right? So we cannot also use it as reference surface in case of satellite based positioning system. So these are ruled out. These two surfaces are ruled out. These are two physical surfaces and have been ruled out. Surface of the earth cannot be taken as reference surface, and this sea surface also cannot be taken as the reference surface for measuring the levels of the earth, isn't it? Then what is the option with us? Okay, we don't have option. Because we have only these two surfaces which can be taken as reference surface, and these cannot be taken as reference surface because are dynamic, irregular, right? So they are changing. So for to overcome this problem, the scientists have come out with a solution, in that they have assumed a figure which is a mathematical, which is not a physical. Okay, only values are there, and that is the ellipsoid. Why ellipsoid? Because the earth is also like an ellipsoid. Is it clear?
Yes, sir.
So ellipsoid is used in satellite-based positioning system. In case of Navistar GPS, WGS 84 ellipsoid has been used. Why? What is the full form of WGS84? World Geodetic System. It was defined in 1984. That is why it is called 84. WGS 84. Department of Defense defined the WGS 84 in 1984, and it has been used in satellite-based positioning system since then. And it is a global data or global reference system. Okay, why it is global? Because across the globe, its surface is plus or minus 50 meter from the geoidal surface. This is geoidal surface. So it will be plus or minus 50 meter from the geoidal surface globally. Okay, otherwise datums are also there in the world, but they cannot be global. They can be local, like Everest 1956 in case of India. We have Everest datum. That cannot be a global system because it will, if you go to the other countries in West and in other parts of the world, the difference between the Everest surface and the geoidal surface will be huge, large. Okay, so the value which we get will not be understandable. Okay, so that Everest is not a global system; it's a local system. Okay, but WGS can be used as global data because it does not vary more than 50 meter from the geoidal surface. Okay, it's clear, I think. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Now come on to the, I'm just coming after, maybe it is not in the flow, coordinate system, right? From the, directly I'm coming from the datum to the coordinate system because at this point it is also important to know about the coordinate system. So how a coordinate system is defined. Okay, so in defining coordinate system we need to have the location of origin, orientation of axis, the parameters of the datum, one or more standard parallels, central meridian, its scale. In together 7 quantities are needed. What are 7 quantities in defining coordinate system? 3 components of location of origin, 3 components of the orientation of the axis, and the scaling. Okay, but 1, 2, 3, 4, 5, 6. No, so 3, 3, and scale. Okay, and these are actually parameters related to datum, not the coordinate system. That is why has not I will not count these here. Okay, parameters of the datums are different from the coordinate system. So in defining coordinate system, we need to have location of the origin. 3 components means x, y, z. What is 3 component means? Component here, x, y, z of the origin, x, y, z of the axis. I mean direction of the axis, x, y, z. How axes are going, x-axis, y-axis, and z-axis. So 3 and 3, 6, and the 7th quantity is scale. So by these 7 quantities, we can define a coordinate system. And datum, when we say of datum, we need to have parameters of the datum. And this standard parallel is also related to the coordinate system, not the data. A central meridian is also needed for the coordinate system. Okay, so these are also required. A central meridian and standard parallel will also come in the coordinate system. So in defining coordinate system, we need to have these parameters. So here I have shown you, I am trying to show you two-dimensional coordinate system. Then it's three-dimensional coordinate system. Just see in this plane, you have x-axis and y-axis, and this is the point. How this point can be defined? So the displacement of the point in two-dimensional plane along the x-axis is the from the y-axis towards x-axis is the x-coordinate, and from the x-axis along the y-axis is the y-coordinate. So in coordinate system, the values we get are obtained like this. So if you say in two-dimensional plane, this is the point. So what is the value of for this point x and y? That is the displacement of the point from the x-axis along the y-axis, parallel to the y-axis. That is the y, and parallel to x-axis is the x. Right? So say so 1 meter and 1 meter. So point from the, if I say 1 here, 1 here, that means the point is 1 meter from the x-axis and 1 meter from the y-axis, parallel to x-axis and the y-axis. So this is one frame having origin here and two axes, x and y, and in this plane we have points, and we can define the positioning of all the points taking distances from the x-axis and y-axis. Right? And in case of three-dimensional, positioning, z is actually not the distance from z-axis. Z is the height from the ellipsoidal surface. So x displacement from the x, displacement from the y, parallel to x and parallel to y, is the x coordinate and y coordinate. Right? So say this is the point in this three-dimensional frame. This has been plotted on this plane, horizontal plane, projected here, and then displacement of this point is measured parallel to y-axis, and from y-axis parallel to x-axis, and whatever value we get is the x and y coordinate of this point, and height will be measured from the surface, not from the z-axis. Right? Z-axis is only in case of the three-dimensional coordinate system, WJ34 or Everest or whatever, it is for alignment. But here it has been shown in this diagram, but it is just for the direction. Again, you just understand here geodetic or geographic coordinates. Geodetic oblique geographic coordinates. So geodetic and geography are same coordinates, same, and Cartesian coordinate is different. So geodetic height of this point and geodetic coordinate of this point how are obtained? In case of receivers, GPS receivers, we get x coordinate, we get y coordinate, we get latitude, we get longitude also. So where from they are measured, how they are measured. So that is actually I wanted to tell you here. Okay, so you just know, at least it is very important to know what we are getting and how it has been measured. Okay, say this is one point on the surface of the earth. If this, through this point, if we draw a perpendicular, it will land here in the equatorial region, okay, of the figure. This is one figure. If this figure is divided by a plane into two equal halves, okay, above and below in the equatorial region, then it is we call equatorial plane. Right? And in this figure, we have semi-major axis and semi-minor axis because it is an ellipsoid, right? As I told you earlier, that we use ellipsoid in case of the GPS measurements. WJ34 is used datum. So in this ellipsoid, we have two axes. One is semi-major axis, other one is semi-minor axis. In the polar region, towards the pole, the radius is smaller. That is why it is semi-minor axis. and in case of equatorial region, the radius is more, so it is a semi-major axis, major axis, right? So in the equatorial plane, the line perpendicular through this point is coming here. Now angle between this line and the equatorial plane is the latitude. Did you get my point? Angle between in vertical direction between this line, which is through the point on the equatorial plane, and the equatorial plane. So angle between equatorial plane and the line is the angle of latitude. Okay, then is the longitude. How do we get longitude? The longitude is measured between the 0-degree meridian plane and the plane passing through the point. So if we draw a plane here, it will go like this. See, imagine it is one plane. Okay, this is one plane, vertical plane, which we consider as 0-degree. Okay, and angle between this plane and another plane which is passing through the point will go like this, and this angle is the angle of longitude, red line here, and it is measured in the equatorial plane also. Horizontal angle and this is a vertical angle. Horizontal angle between two planes, one this and another will be here. Imagine that one plane is also here, similar to this. So angle between, if you cut a apple, take a slice out, then you will have two surfaces. One will be here and another will be here. So angle between these two surfaces is the angle of longitude. Angle of longitude. So these are geodetic coordinates. So in this figure, you can see the equatorial plane, you can see the ellipsoidal surface, pole, like just wait, I have pole. हाँ सर, हाँ मैं सर एक लेक्चर ले रहा हूँ ऑनलाइन। हाँ मैं वो कोई इनवाइट किया था सर, हाँ बस अब फुल डेमो होने वाले हैं। हाँ कंफर्म हो गया? ठीक।
Hope each and every participant is enjoying the lecture.
Yes, sir.
Yes, sir. We
Yes,
are
sir.
attending.
I can assure you that Dr. V.S. Rathore is one of the best
Sorry,
in the field of GPS technology in India.
So sorry, Suraj, I had some call.
नहीं सर बहुत बढ़िया, बहुत तारीफ कर रहे हैं बच्चे, बहुत सारे चैट्स में आ रहे हैं, बहुत बच्चा एंजॉय सर को बोल रहा है कि सर को कहाँ छुपा के रखे हुए थे।
We are continuously attending.
Thank you so nice. So latitude and longitude, and then know about the WGS84. I'll be on the WGS84, right? So in case of WGS84, the minor axis, major axis, and then the 0-degree meridian plane. Where is the 0-degree meridian plane of WGS84? Where is the x-axis and y-axis, and what is the z-axis? In which direction z is going, right? So see, this is very important because now in this time, all of us are using GPS receivers, right? Most of the people who are in the field of remote sensing GIS GPS, you are using GPS in some or other way, maybe directly or indirectly. Either they are directly using or they are using the data, okay, obtained by someone else. So we all are now in this field. So it is very important for all of us to know about the values, what we are getting from GPS receivers. So where from these values are coming, where from these values are measured. So these values are measured in WGS84, right? So that is one ellipsoid, mathematically defined, imaginary. It does not exist physically, as I told you in the beginning, that we have surface of the earth, we have the geodetic, geodal surface. So we cannot use the surface of the earth as reference surface. We cannot use the geodal surface as reference surface. So what can we do? So to have the values, to get the coordinates, we imagined a surface, mathematically defined. So somewhere we defined the center, somewhere we defined the x-axis, somewhere we defined the y-axis, right? And the z-axis, then we got the orientation, then we defined the prime meridian, okay? Then we are getting the values. So that is the point. So in case of WGS 84, center of WGS 84 is 100 meter away from the center of mass of the earth. Just 100 meter, right? Okay, 100 meter away from the center of mass of the earth. And we are getting 50 meter plus or minus from the geodal surface. The surface of the WGS 84 is 50 meter plus or minus from the geodal surface. Okay, equigravity potential surface, as I told you. So now we have the center. Where is the center? Center is 100 meter from the center of mass of the earth, WGS 84, right? Then where is the z-axis of the WGS 84? Z-axis of WGS 84 is aligned in the conventional terrestrial pole defined by the International Agency for uh, Earth's rotation, right? There is one international agency that is known as International Agency for Earth's Rotation, that defined the CTP. CTP is nothing but a north pole, right? Conventional terrestrial pole. So CTP is defined by International Agency for Earth's Rotation, and that is the north pole, right? So different agencies or different countries have defined the north pole, right? But the z-axis of WGS at 4 is towards the CTP. It is in the direction of CTP, right? So from the center, we have got now z-axis, right? So z-axis of WGS 84 is in the direction of CTP, conventional terrestrial pole defined by International Agency for Earth's Rotation, right? Then they have defined the 0-degree vertical plane, right? This is required to know the longitude or x values, right? So 0-degree, where is the 0-degree in case of WGS 84? 0-degree is defined by a plane which is passing from the north pole to this towards south, and it is coinciding with the Greenwich meridian plane. We have a Greenwich meridian plane that you are knowing in geography, right? A Greenwich meridian plane has been assumed as 0-degree. So in case of WGS also 84, in case of WGS 84 also, the 0-degree meridian plane is coinciding with the Greenwich meridian plane. So now we have this prime meridian plane, which is 0-degree in case of WGS 84, right? So we have got now this plane also. Then we have equatorial plane, this green line. In case of W, it is dividing the WGS 84 figure into two equal halves, right? So now we have here one intersection of 0-degree meridian plane and equatorial plane. Do we have? So at the intersection of this 0-degree meridian plane and this green line, which is equatorial plane, we have x-axis, right? So x-axis of WGS 84 is where? It is at the intersection of 0-degree meridian plane and equatorial plane. Then where is the y-axis? Y-axis is right 90-degree from the x-axis towards east in equatorial plane. This is a y-axis, right? It is 90-degree from the x-axis. It is in the equatorial plane and it is in towards the east. This is north, this is west, sorry, south, this is west, this is east. So where is y-axis of WGS84? It is towards east, 90 degree from the x-axis in the equatorial plane, right? So we have now got x-axis, we have got y-axis, we have got z-axis, we have got the center of WGS84. So this is also known as Earth Center Earth Fixed Coordinate System. Why? Because its center is in the center of mass of the Earth. Its z-axis is aligned to the CTP pole. Okay, so that is why it is also known as Earth Center Earth Fixed Coordinate System. Clear? So now we have x-axis, y-axis, z-axis to define the direction, 0 degree meridian plane. So for any of the points, we can get the x-coordinate, y-coordinate, latitude, longitude things. So how do we measure? That will come. Okay. So just now also see the parameters of WGS84. Parameters of WGS84s are like this. Semi-major axis length is 6378.137 kilometer. Semi-minor axis length is 6356.7523 kilometers. So just see these values: 6378, 6356, 137 kilometer. Okay. So and flattening will come from this formula a minus b upon a 1 by 298. So this is the flattening of WGS84. Now why I am showing these parameters? Just to compare with the average 1956. So average 1956 is the datum used in our case of our topographic maps. Survey of India using this datum. So what is the point here? Just telling of these two things is that we have one information in our topographic maps, that is in average 1956, and another information from the GPS receivers, that is in WGS84. These two are different. So coordinate what we are getting from the GPS receivers is different than the coordinates we get of any of the feature from topographic maps, right? So in WGS84, suppose we take the positioning of any of the feature from GPS receiver will come, we will have some different values, and the same feature if you take from the topographic maps, you will have x and y and latitude longitude different because of these values. See, in case of average 1956, where is the z-axis? Z-axis is along the mean polar axis, not along the CTP. So there is angular difference, right? So mean polar axis, semi-minor axis, which is z-axis. Z-axis of average 1956 is in the direction of mean polar axis of Earth's rotation. And in case of WGS84, z-axis is in the direction of CTP. So both are going in different direction and there is angular difference. So that will also come in the positioning. Then the size, there is difference in size. Semi-major axis of average 1956 is 6377.3012 kilometer, and see here 6378, 63. So some 1 kilometer difference is there, 7877, approximately 1 kilometer difference is here, right, in the length of the semi-major axis. Then in the semi-minor axis, 6356.10, 635675. So 700 meter approximate or 600 meter of length difference is also there in semi-major axis. So which one is smaller? Average is smaller than the WGS84. So here flattening of average 1956 is 1 by 300. Which is more flattened? The higher the value, here 1 by 2 is more flattened or 1 by 10 is more flattened. 1 by 2 is always more flattened. It is half almost. So WGS84 is more flattened than the average 1956, right? Okay, so because of these differences in this shape and size of the datum, average 1956 and 84, we get different values of x and y and height. X and y related to longitude, right? So this much I would like to tell you today because of time limitation. Suraj, is
हाँ
it
सर
okay? Is it
हाँ जी
okay
हाँ
for tomorrow today?
more than enough sir more than enough means it more session we had today on GPS. I doubt that anybody else except you in India can teach in detail about GPS technology. We are very fortunate that from your busy schedule you have spared time with us, your extreme knowledge, the experience, the mode of operances, the different kind of surfaces. So it was a outstanding talk by Professor V.S. Rathore, who has a mentor for me today. Whatever I am, it's because of his able guidance. He has taught me the software. He has taught me the GPS. Software and the instrumentation. So today, whatever we are, he's the instrument or he's the mentor uh, for framing us. And also, I thank to the participants that you'll be taking this and we'll be doing some lab exercises related to that in coming days. And this, I thank Professor V.S. Rathore that from his busy schedule, he has given us in detail knowledge about this technology. Now, if anybody has got any questionnaire, 5 minutes of questionnaire around we can have so that it cannot be a one-way mode. It must be interactive mode like
Right.
Vikram Ranga had a few good questions towards Professor Rathore. And if you have got any questionnaire, then we'll proceed. If not, then sir has got some other schedule. He'll be signing it off. Anybody, if you want to have, you've got 5 minutes to ask.
Yes, sir. I wish to say a few words. Thank you very much for a very informative lecture.
Thank
And
you.
I am a great admirer of your work, sir. I have
Thank
read
you.
a number of papers from you.
Thank you. Thank
And
you.
as Professor Singh also said that you are mentor to him, I also expect that you be mentoring many of us, including myself.
You're welcome. Yeah,
In
I'll be happy. I'll be happy.
I will contact you through Professor Singh, sir.
Sure, sure, sure. I'll be very happy.
Okay. Thank you very much, sir.
Thank you, Vikram.
Anybody, any question?
Sir, good morning. I'm Dr.
Good morning.
Sarvan Kumar.
Yeah.
Actually, sir, my question is, as you told that during the signal processing, uh, the signal is delayed by some atmospheric processes. So, can we study also to study the atmosphere for these delay signals?
Yeah, people are studying. Okay, some ionospheric models exist, but in case of tropospheric study, modeling is difficult because in the direction of signal, we don't have information of temperature because moisture content plays important role in the tropospheric delay. So very difficult to get temperature information. That is why modeling of tropospheric delay is difficult. However, there are model about ionospheric delay. So people are taking average for tropospheric delay also. Whatever delay in ionospheric region are also average of that is taken for the tropospheric delay. And for dry component, there is a very simple equation. But in case of dry component in tropospheric, actually the delay is because of, as I told you, because of moisture content and because of the dust particles, right?
Aerosols, yes.
Aerosols. So for estimating delay due to dry component is simple. It is given by a very simple formula, that is 2.27 into zero point 0.001 multiplied by atmospheric pressure. So from that we get the delay due to aerosols. But getting delay due to moisture content is very difficult, because for that we need to know the temperature variation in the direction of signal, right? So we don't have instruments in the atmosphere to know the temperature variations along in all the directions. So in that part, we are just
So
assuming.
ionospheric measurement can be done by
Yeah,
GPS.
it is electron content. Total electron contents are measured, computed,
Okay, sir.
and so many equations are there and models are also there. So people are also even then people are doing work. What is the total electron content over Ranchi area? What is total electron content over Banaras or
Yes.
over any other region? So if that you know, then you can find out the delay.
Okay, sir. Thank you, sir. Thank you.
Welcome. Any other
Anybody?
question?
Anybody else?
Sir, I have a question, sir.
Right.
Sir, what is the difference between datum and ellipsoid, sir?
Ellipsoid.
Ellipsoid,
So
sorry,
there
sir.
is no difference in ellipsoid and datum. Actually, we have, in case of GPS, they have assumed an ellipsoid, which is actually approximating the surface of the Earth. Data means reference surface, and ellipsoid has been taken as reference surface here.
Okay,
So
sir.
there is no difference. But if you say, is there difference between coordinate system and datum, then there is difference.
Yes, sir. Okay. Thank you, sir.
Welcome. Any other question?
If not, then we'll feel that sir has done on his work for today. Now we'll proceed for our next session. Our eminent speaker from Jamia Millia Islamia has joined us. And thanks, Professor V.S. Rathore, sir, from Birla Institute of Technology, Mesra. Thanks a lot,
Thank,
sir.
thank you, Sujal, for inviting me. Thank
Thanks,
you.
sir. Thanks.
Thank you.
Thank you so
Thank
much,
you
sir.
so much, sir. Thank you so much, sir, for sharing such an in-depth lecture on the subject matter of GPS. Thank you once again. Now, let me introduce to our second speaker of the day, Dr. Praveen Kumar Pathak, sir. Dr. Praveen Kumar Pathak, sir, is currently working as an associate professor, Department of Geography, Faculty of Natural Sciences, Jamia Millia Islamia University, New Delhi. He received his MS in Geography from Banaras Hindu University, MPhil and PhD from in Population Studies from International Institute of Population Sciences, Mumbai, India. His area of interest includes social networks and demographic behavior, geospatial analysis of population, environment and health, population and development policies, spatial and quantitative methods. He has more than 18 publications in various international and national journals. He has also received many awards and distinctions, such as received grant to participate in international workshop on subnational uh, population projection in Asian Demographic Research Institute, Shanghai University in China in 2017. Guest researcher in Veni Institute of Demography, Austria, Academic of Sciences in 2014, Population Reference Bureau Policy Communication Fellow Program in Washington, D.C., USA in 2013, Young Scientist, Luxembourg, Vene, Austria in 2013, and many more. And many more. Also, he is the member of various professional bodies such as the International Union for the Scientific Study of Population Association of America, Indian Association for the Study of Population, Asian Population Association, Indian Association for Social Sciences and Health. Sir, we are very delighted to have you here and welcome you to start with your training session. Sir, please.
Good morning, everyone. I want to thank Dr. Shruti ma'am, Dr. Suraj, and the entire team behind organizing this very important program on geospatial training. And I wish to congratulate all the coordinators for this very wonderful program. Uh, so, as I want to thank Upasna for giving this brief introduction about me. And so basically today what I'm going to do is that I am working in area of population and health geography, and we use spatial analysis to examine important question of how geography and public health and socioeconomic environments are correlated. So what I'm going to do in the next 45 minutes or 1 hour is I'm going to take you through some of the examples of how these sort of questions may be addressed using geospatial technologies. So if you think about spatial analysis per se, so spatial analysis is a very useful technique to make sense of different questions that we usually come across in our day-to-day life. If you think about economists, if you think about anthropologists, if you think about political scientists, so most of these disciplines tend to view different human behaviors from individual perspective, है ना? So they tend to look at the way people make, for example, shopping behaviors, or the way people make political choices in terms of casting votes, or different population level behaviors, right? So most of these processes that operate at individual level, but we as a geographer or people those who are looking at spatial processes tend to model these behaviors at aggregate level, right? And this is a very useful thing to do if we want to find out how macro level processes influence human behavior. So as a geographer, there are various examples that we come across in our day-to-day life where we can integrate the macro level environment, for example, social environment, economic environment, your physical environment. How can we operationalize them, and maybe we can see association between individual level behaviors and macro level characteristics. So the way I'm going to do is that I'm going to take a couple of examples and show you what are the different tools and techniques and methods which are available and can be widely used for the association. So if you think about population geography or health geography, the basic idea is you try to make correlation, or you try to see association between certain outcomes. So for example, this is a very famous study by John Snow, considered as one of the pioneers in the field, where he was basically looking at spatial distribution of certain epidemiological outcome variables. So for example, he was looking at spatial clustering of deaths, and one of the in city of London during 1850s, and he was trying to understand what if you look at the way these deaths are distributed, they are not randomly distributed over this space. So if you look at the spatial structure of this death, so there are different points in space where the death seems to be more clustered. So in this map, if you see the area near A, and these places in the center of this map, you find deaths to be more clustered as compared to these exterior portions. So he was trying to figure out, what may be the possible mechanism driving these, clustering of deaths in certain pockets of London. And as you know that, he came out with a hypothesis that it was basically because of the hand pump, which had some contaminated water, and which led to higher concentration of death in certain pocket of the city of London, right? So this was the first kind of study that was trying to look at association between environmental processes on the ground and how that was overlaid with distribution of health outcome, that was death in this case in the city of London. There was a recent paper that came in the Sciences that talks about spatial turn in health research. So what does it basically say? It says that we can use spatial technology to a great deal in terms of decision making by virtue of overlaying different layers of vital information, and that provides us a very unique perspective to come out with place-based policies and decisions. So for example, that talks about, if you look at this simple image, so what they do, they try to model individual outcomes as a result of exposure to environmental risk and hazards, and you can overlay that with the local socioeconomic configuration of population, and of course you can overlay with the health system capacities. So if you can put these vital information on a spatial platform, and you can integrate, you can manipulate, you can transform the data. So that allows you as a researcher a huge leverage in terms of making informed decisions and find out major hotspots or major clusters where you have a specific disease or health outcome. Even today, like I mean, in the last 2 years we all have been grappling with COVID-19, and a lot of research in the last 2 years has been looking at this problem not only purely as a biological phenomena. Rather, we also know that the health is very much social and economic behavior as well. So to what extent can we model these social and economic and psychological and health system capacities at the spatial scales and figure out vulnerability on the ground, so that we can what is the benefit of this approach? The benefit is that we are able to target our limited resources with more precision on the ground. So that is the leverage that we get when we use these scientific tools and methodologies to identify these changing pattern over the period of time. Kai bar, various times this also happens. For example, if I talk about the city of Delhi, so I mean, Delhi, we have more than 11 districts and there are more than 150 wards. And if you look at these administrative boundaries, they are very much, if I may say so, not natural boundaries. These are administrative boundaries. These are very much created for administrative convenience. But there are many such behaviors which do not follow these administrative boundaries. For example, if you are living in a neighborhood in some part of a Delhi, right? It may be a economically well-off neighborhood. Some of the neighborhood may not be economically well-off neighborhood. So many times, you come across this problem of spatial spillover effects, right? So for example, you happen to live in an area where you have, for example, I live in South Delhi here, and then you have nearby neighborhoods which are economically not so well to do. So many times when you happen to live in such kind of neighborhood where there is a threshold of different characteristics, so the impact of other neighboring neighborhood will be felt on the first neighborhood, right? So in this way, these kind of spillover effect is in economics we call it spatial externality effect. So if you have certain things which is positive in one neighborhood, this impact will go on to the neighboring area which may not have something very positive. So therefore, as a geographer, as a spatial scientist, we try to extrapolate these kind of spatial spillover effects, spatial externalities. Many times this is also known as copycatting kind of thing, where certain things happening in one neighborhood may be copied in other neighborhood. This may be positive, this may not be positive. So all these sort of behavior provide you a very unique opportunity to make certain policy and programs in order to improve environmental outcomes, even health outcomes. We all today are also facing this problem of chronic air pollution, and different governments and policymakers are trying to quantify who is the culprit, from where this pollutant is coming, and how to fix responsibilities. So for many such questions, I think this spatial analysis has a very powerful tool that can allow us to quantify some of these behaviors, right? And can allow policymakers to make a lot more dispassionate decisions in policy circles, right? So we as a geographer, population and health geographer, what we try to do is that we try to look at how in a given area, if you look at demographic variables, for example, age composition of population. So what happens if you look at the population composition in an area, it is not homogeneous, right? There's a lot of heterogeneity in terms of age composition of population. Why does it matter? It matters because suppose if you live in an area which is predominantly occupied by young students, university college students, so because of the predominant composition of young people in the given area, you have a very different set of culture, economics, politics. And likewise, if you happen to live in an area which is predominantly occupied by older people, will have a very different kinds of connotation for for health, for social life, for entertainment life. So therefore, we as a geographer try to model implication of these spatial composition of places and how they have impact on social behaviors, economic behavior, health behavior of areas, right? So we have done some work some time back. We were looking at, basically what we did was we classified India into 76 natural geographic regions based on, of course, climate regimes, agriculture output, and such and other variables, made India into 76 natural regions. And we were trying to look at, whether the burden of infant and child mortality in India, does it vary, and what may be the factor that may lead to these spatial variations across the 76 regions, and why it is important to know. Why? Because, largely, in terms of at the national level in the country, or even at the state level in the country, we tend to look at these development issues at macro level. Either at the state level, Gujarat is doing well, Kerala is doing well, UP is not doing well, Bihar is not doing well. So we tend to rather simplify this complicated issue at the macro level. But based on research and understanding from previous studies, we know that within each state there is a huge spatial variability. And if you mask them at the state level, you tend to ignore a lot of problems that may exist in so-called well-off state. And likewise, there could be multiple things which may be positive in some problematic states as a whole, but then again, you tend to exaggerate a problem which may not exist at the first place. So in terms of finding out uh, the exact magnitude of the problem, and do not mask it at the state level, but rather dig into a meso or micro level. So from that motivation, we were looking at whether, infant and child deaths in India do follow any regional patterns, and if so, what may be the causal factor responsible for the same. Right. So our hypothesis was basically in the study to understand whether, burden of poverty, economic deprivation, extent of female literacy, and poor nutrition among children, whether that has any spatial structure in the country, right, at the regional level. And if so, whether it has any association with the burden of infant and child death in India. And we have looked at different rounds using NFHS and district level household surveys since 1990 onwards, and trying to use some quantitative spatial analysis to make some sense about, how these things are spatially clustered and how it may be quantified, if there is any relationship at the spatial scale or not. Because at the individual scale, we know that, there are certain characteristics, demographic, economic, and environmental factors which work. But whether we can actually, scale it up at the regional level, and we can find some spatial patterns or not. And why it is important? It is important because if you think about many of these variables, either it is health, either it is environment, they of course operate at individual level. But if you find there is some collective problem at a macro level, that also need to be addressed urgently. Why? Because if you think about, epidemiology or public health, we tend to understand, health problems at two levels. Either at, some factors which are known as upstream factors, jisko bolte hain macro factors, which is basically at aggregate level. So if you want to, for example, if you want to improve maternal health of any area, one of the reasons could be how to make behavioral change. So for example, behavioral change, like if you want to increase the acceptance of institutional deliveries. So for these sort of behaviors, you have to work at the upstream level, at the administrative level, at the policy level. Similarly, you can also do some downstream thing. You can go and reach to each and every individual woman and tell her about, inform her about, the benefits of, for example, going to nearest health facility and seek antenatal care, natal care, postnatal care, consuming IFA tablet for, and of course other health supplements while pregnancies. So there are a lot of things one can do at micro level in terms of making change on the ground to improve health of pregnant women. Likewise, there are a lot of things that we can also do at the macro level, wherein we can, at the policy level, make some intervention. So therefore, it is really useful thing to, if you want to work at micro level, you go to individual, talk to them and do some work. And likewise, you can also do macro level efforts in terms of policy and bring some changes at macro level and do some changes. So the motivation for this study was, if we can identify the regional level, macro regional level patterns. So whether there are certain regions in the country that are at a disproportionately higher risk of, for example, burden of infant and child death in the country, and what may be the factor associated with these sort of health problems in the country. And if you can model them, and we can show that these results are statistically significant, these results are robust, then probably it can help to provide some evidence base for policymakers to take a informed call. So, I mean, if you start with any spatial analysis, basically what we do, we basically tend to, graph or map the descriptive statistics. So for this instance here, what we do is that we look, we estimated the infant mortality rate in the country in the year 93, 99, and 2004, and we plot these maps across these 76 regions, and it very clearly shows, the red color regions are the regions where we have disproportionately higher burden of infant deaths, and likewise the under 5 mortality rate in the country. And over the period of time, we of course show that even if the burden of the absolute concentration of deaths is going down, yet we observe that there is a marked clustering of this death in the central regions of the country and part of the eastern region of the country as compared to the south and the western regions of the country, right? So this is very clear from the descriptive statistics. So like, in the case of John Snow, when he was looking at the distribution of deaths across the city of London, one can also do at regional level, you can do at village level. So it depends upon the availability of data. I mean, one of the biggest problem in any research is whether you have data and up to what level the data is available, right? So in such cases where you want to estimate infant and child deaths, it is very difficult to get these data at, village level or urban ward level. So what we do is either we estimate them at the max district level, or we can even go up at the regional level, right? State level and country level, it is readily available. So we first estimate this burden at different regions of India, and we show that there are certain regions where the risk of death among infant and under 5 children is disproportionately high over the period of time consistently, right? So which means that there is something special, there is something unique in these group of districts which makes them very different as compared to if you look at districts in the south or in the northeastern part of India or the northern some of the northern regions in the country, right? So what unique thing, what black box is this, and how can we explore them, right? So of course, if you want to answer these questions, there are two things. One is based on theory, we identify certain factors which have been historically known to be strongly associated with the risk of infant and child mortality in the developing countries. Second is, of course, as I said, availability of the data that also limits our ability to analyze these determinants and risk factors of under 5 mortality in the country. So the first thing what we did was we just run a descriptive distribution of looking at the clusters, right? Then we are here looking at the possible risk factors of things that might be associated and allow us to explain these spatial patterns. So previous map shows us infant and child mortality patterns in the country across 76 regions over the period of time, and we conceptualize that there are certain factors which may be associated at the regional level. Mind you, these are all estimation based at the regional level, right? So we have scaled up individual behaviors at regional level. So first factor is which we consider is the burden of poor household in the country, and you can clearly see this poverty is again spatially clustered. It's not like very random. There are certain regions that tend to be grappling with economic deprivation over and over the years, and that's what we see. So largely the central and the eastern regions in the country, shown through these dark colors, show you the major areas where regions particularly where we observe huge concentration of poor household in the regions of India. And when we look at proportionate underweight children in the country, because if you want to understand mortality among various factors, we know that economic deprivation is one important factor. The second one is proportion underweight children in the country. And if you look at 1992-93 patterns in the country, it was like entire landscape of India was very much affected with the problem of underweight children. Although over the years it has come down, yet we have around 35% of children in the country still continues to be undernourished. So again, if you look at these spatial patterns, we observe that there are certain regions in the country in the central part of the India largely, where this problem of undernutrition or poverty is concentrated. Yeah, so this is the descriptive part of the things. When you begin this spatial analysis, you try to summarize the data and you try to identify the descriptive thing, right? Now the second important step is, well, of course, this is a map of India which does not represent the correct political boundary, so we have put a disclaimer. Now, so what we show here, so if you think about spatial analysis, there are different techniques that we can use, and one of them is basically you can use local indicator of spatial association, which is also known as LISA maps. So these are maps which are generated in a software called Geoda, which is a free access open software which has been used to generate these LISA maps. So LISA, this is a univariate LISA, right? So basically what we are doing here, we are looking at the clustering of spatial clustering of under 5 mortality and underweight children in the country. So it's basically there is a very famous law in geography called known as Tobler's law, which says that everything in this space is related. Okay, closer things are more related than distant things. Similarly, if you tend to find you try to find association between problem of undernutrition or problem of under 5 mortality in the country, we map them using the univariate LISA technique, which is nothing but, what it does is that you have these districts or you have these regions, and they use spatial weights to find out the degree of association between one variable, right, between the neighborhood districts, right? So areas that tend to have stronger association has been shown through these high risk group, which is red color here. And if you have areas that have very lower risk of in this case, I think under 5 mortality, are shown by dark blue colors. And we also have we can also identify not only the hot spots and the cold spots using univariate LISA, but we can also identify something known as outliers as well. So there may be certain places which may be very unique, and you can run these univariate LISA map, and they will show you, if there is any outlier about relationship. So in this map, we are basically looking at one variable, which is in this case under 5 mortality rate. We plot it across the regions in the country, and through this univariate LISA map, we identify the local association of under 5 mortality across regions. So these red areas are nothing but regions where high cluster of under 5 mortality rate is observed. Blue colors are area where low risk of under 5 mortality is clustered. Beta map. Yeah, thank you. So this is the LISA cluster map. These green color maps are LISA significance map, right? So as you know that if you run these statistics, you need to figure out if these relationships are statistically significant or just by mere chance. So the dark green color shade is the p-value of 0.001. So it is statistically significant at 1% level of significance, saying that, these results are very robust, right? So this is one technique. Now, so this is an improvement over the previous map. This is a simple descriptive map. Here you can identify the hot spots and the cold spots, as well as you can identify the outliers if there is any. In this case, I don't have. I will show you later. This is a bivariate LISA map, local indicator of spatial association. Now, again, we move one step ahead. And here what we are doing is that we are looking at association of under 5 mortality with our independent variables. So which is poverty, which is female literacy, which is underweight children, which is safe delivery. So we are looking at, how under 5 mortality, spatial distribution of under 5 mortality in the country is associated with spatial distribution of each one of these individual factors, right? So here, if you may see, these are I think A is bivariate LISA of under 5 mortality with poverty regions in the country, right? So this is simply like if you plot a scatter plot, on the x-axis you may have poverty, on the y-axis you have under 5 mortality, so you have the scatter plot x and y. And likewise, if you do it on the map, here using bivariate LISA, we can show it spatially as well. And again, we can find out, two different variables. And therefore, we show here cluster of in the map A. Yes, beta. 12. ये मेरा ड्राइंग बुक है, ये रख देना. ठीक है, I'll do that. Thank you. Right, sorry. So these are, if you look at map A, we have this bivariate LISA map showing us the association between I mean, the red color shows you higher area, higher burden of under 5 mortality, as well as higher concentration of poverty, right? Here. The blue area again shows you areas where you have higher burden of under 5 mortality, sorry, lower burden of under 5 mortality and lower burden of poverty in this area, right? So you have hot spots and you have cold spots. If you look at these areas, these regions which show you low burden of low burden of under 5 mortality and higher concentration of poverty, right? So these are some kind of outliers. Similarly, this is also an outlier, right? And these are statistically significant, which can be easily observed through the LISA significance map. So in this way, you can run these multiple bivariate LISA maps, and you can figure out which regions in the country are really burdened with a particular problem and what may be the factor associated. So here we show under 5 mortality by poverty. In map B, we show under 5 mortality by female literacy, right? So what it shows, areas that tend to have higher burden of under 5 mortality and lower concentration of female literacy are these regions, right? Because this is a negative outcome, which is under 5 mortality. Female literacy is a positive independent variable. So here you see that it is high and low. Here again, you have higher concentration of female education and lower burden of poverty in the southern states of India, right? And likewise, we look at the significance map and we can find out if these relationships are statistically significant or not. So in this way, this bivariate LISA is another important method that allow us to kind of do a cross tabulation and cross association of our outcome variable with our set of independent variable. This last map is about under 5 mortality with underweight children. So it's pretty straightforward. Both are negative in terms of outcomes. So higher concentration of under 5 mortality tends to be more in areas where you have predominantly huge cluster of undernourished children, right? And the dark blue is, so these are the hot spots. These are the cold spot, if I may call them. Now, this is again, we are using these bivariate LISA. So it's just an extension, and we show here, how under 5 mortality in this country varies by other important characteristics that I discussed in the previous graphs as well. This is spatial clustering of under 5 mortality by bivariate LISA. Spatial clustering by female literacy, spatial clustering under 5 mortality by safe deliveries using bivariate LISA again. This is interesting, residual maps are very useful things to understand, how outlier may be observed, and then how we can plot them using, these maps. And this is very useful information. So as you all know that, residuals are basically result of, if you model any outcome, you have certain predicted value and certain unexplained variation in the model, which we refer to as residuals. And if residuals are spatially clustered, it means there is something very unique that is happening in certain areas, which through our model we are not able to explain because these are unobserved characteristics. But there's something you need to be dig more into to identify why a certain problem exists here, right? So if you have a residual map, if it is purely random, if there is no clustering, everything your model done well. But if you have residual map with spatial clustering, it means that there is certain spatial uniqueness in certain outcomes that is to be investigated in detail, right? So we also use Moran's I, which is a global indicator of spatial association, which can quantify the association in any outcome using this spatial data set, right? So Moran's I is an indicator of spatial association, and it's basically a quantification. LISA, univariate LISA and bivariate LISA is basically, you can plot this association, and when you want to quantify the association, one can use global Moran's I index. So the higher the value, greater is the degree of spatial correlation, and lower the value, lesser is the degree of spatial dependence in the data set. And here we basically model, infant mortality, under 5 mortality, accounting for space and time. So, usually what happens in demographic and public health literature, we tend to look at this association at individual level, because rarely we have this data where we can do this environmental and aggregate kind of analysis. This was, we published this study in 2011. So then it was one of the, in Indian context, first studies that were looking at such kinds of association at the spatial scale. So, so when you run this kind of spatial regression, the whole thing is that you have to account for the role of space in addition to demography, economic, and social structure. So how did we account it for the spatial role of space? Is basically there is a lot of different kinds of spatial weight opportunities which are available in geoda. You can create the spatial states. It takes the distance between real neighborhoods and calculate weights within this geoda software. So you can use these different spatial weights which is generated by the systems, and you can use them and account for the role of space when you try to explain variability in your dependent variable. In the second study, we were looking at district level spatial patterning of fertility levels in the country. This was a study that we published in 2017 based at the district level. So we use 640 districts as is available from the Census of India of 2011, and we try to model fertility variation in the country using a spatial analytical approach of using GEDA, of course. So here what we did is that for 640 districts, we used total fertility rate as a measure of fertility in the country. You know why fertility is very important? For various reasons, because of various development implications, gender implication, of course, many other reasons why fertility is very critical for any country, right? One of the important these are the list of other independent variables that can be used to explain fertility variation. And the novelty of our study was that we used childlessness, proportion childlessness to, for the first time, to look at the association between fertility and proportional childlessness. There are many couples who may want to have kids, but for some reason or the other reasons, they were not successful in having children, right? So therefore, they were considered as proportionate childlessness. And there are many other determinants from literature. For example, gender preference is a very critical indicator of fertility. Areas where you have huge gender preference ratios tend to have relatively higher fertility on average than other areas. Likewise, areas where you have lower utilization of modern contraceptive methods may have lower, higher fertility than other regions in the or districts, or you can look at either at village level, or you can look at district level. So depending upon data availability, we were looking at using 640 districts of India. We also considered female workforce participation rate available for 640 districts in the country, female literacy, proportionate poor household, proportionate scheduled caste, scheduled tribe population, proportionate Muslim population across districts, percentage of urban population across the district of India, and access to treated tap water. So as I said, one of the indicators to look at district level spatial association in each of these indicators. So we plotted this TFR, right? And we also run Moran's I, global Moran's I, to find out what is the extent of spatial clustering with regard to TFR in India based on 2011 census. And we found that 0.68, which is fairly quite significant spatial patterning of fertility in the country, which means that fertility patterns in the country are absolutely not random. Rather, there is a huge spatial spillover, if you may call it, between districts in the country where there are spatial association. So why that should be a problem or a concern or a subject of interest? It is a subject of interest because it tells you that there are certain unique clusters of districts in the country that have a similar fertility patterns, right? So there is something unique that is happening in these areas or group of the districts which tend to have disproportionately low or disproportionately high, or they may be closer to the average national TFR of the country, right? So there are certain uniqueness which is shared by certain groups of a cluster of districts. Similarly, if you think about other variables, for example, child mortality. Mortality is one of the biggest determinants of fertility. Areas where you have higher incidence of mortality would continue to have higher level of fertility. And here one may say that, across districts based on 2011 census, the Moran's I value, which is 0.75, again confirms that we have a huge concentration of the mortality in selected districts of the country. With regard to gender ratio, the clustering is fairly relatively less because this value is 0.40. So again, we have clusters largely in the northwestern part of India, and where you have huge sun preference in the country, and which is leading to higher fertility in some districts in the country. No contraceptive use, especially clustered. Women marrying below the age of 18 years. I think this is the highest showing higher clusters in the country in terms of districts where you have, so there may be few districts, but again these districts are spatially, adjacent to each other. They are spatial neighbors. So if you want to find out which districts are they, you can of course plot them and you can look at them, and I will show you very in few seconds which groups of districts are these where you have this higher clustering of the child marriages in the country. Moving forward, we have considered other variables, for example, workforce participation, female education, poor household, and these. So these are basically. So the first thing what we do is we first provide the descriptive statistics of our dependent variable and set of independent variables. Second thing is that we run this Moran-I, method to look at spatial association, and we summarize these values, and we clearly, suppose if these values tend to be very low, there is no point in going ahead and do the analysis, right? Because if most of them happens to be spatially random, do not show any clustering, why would anybody want to go ahead and do it, right? So because we find that these values are quite significant, substantial, we wanted to go ahead. So this is how it looks like, so the dark green color are districts in the country which everyone knows have very high concentration of uh, total fertility rate, right? This is univariate Lisa map showing you higher concentration. And again, the dark gray colors are districts in the country that tend to have lower fertility patterns, and remaining areas are districts which fall in between. And so we know, based on literature and everything else, that the central part of India, largely UP and Bihar and some part of Rajasthan and Madhya Pradesh, that continues to have disproportionately higher level of total fertility rate, which is average number of children per woman in her lifetime. This is of course a derived measure. This is not an actual measure of fertility. And our principal hypothesis was, which was very very different and very unique, to figure out if spatially childlessness has anything to do with fertility outcomes. And if you look at the spatial levels, we do see that areas that tend to have lower TFR are also areas that tend to have higher concentration of childlessness couples in these districts, right? And similarly, areas that tend to have higher fertility are also areas where you have very few or absolutely no prevalence of childlessness couple in these areas, correct? So therefore, there was some degree of agreement, or looks like there would be some degree of spatial association going forward. Then we also do these, Lisa maps, use Lisa map to plot the child mortality patterns across districts, 640 districts in the country, which again clearly shows that center and eastern part of India happens to, based on 2011 census, and these are the survey data. So again, when you are working with these spatial analytical techniques, one of the things is that you have to transform, you have to manipulate, and you have to integrate data from different sources. So in this study, we have used some data from census, and some data has been used from surveys, and the estimates has been generated by us to come up with these numbers, and then we plot them using these district level maps of census 2011, right? So we came up with this map which shows us, the problem areas where under child mortality seems to be highly concentrated versus other regions where this seems to be very low. With regard to poverty, the central regions of India, eastern part of India, some part of northeast seems to have higher concentration. On the other hand, these regions are again, places where you have lower concentration of poor households. If you plot no modern contraceptive methods, so predominantly this is the the so-called gangetic plane of India, where we have these predominant clusters of no modern contraceptive, and gender preference ratios seems to be, if you see that, only few pockets you can see in the country where you have the gender preference ratios in the northern, central, and states in India. Now, child marriages are heavily concentrated in the central regions, and part of these, this is Telangana, part of Maharashtra and Orissa regions. Also in Karnataka, few, I think this is Maharashtra, where you have some of the districts where child marriages are very high. Female labor force participation, as expected, we found that largely in the south and the western regions of the country where it's high, and in the entire Gangetic plain, female workforce participation was very, very limited. Now, I think this is bivariate, Lisa, where we were trying to look at association between TFR and child mortality. So this dark color, again, areas where you have high TFR also happens to have high child mortality, which very much goes with the theoretical, foundations where, higher mortality will have a higher fertility. Why? Because if you want to have certain number of children, and if you know that, because some of them will survive, some of them will not survive, of course, people will go for higher family size, and thus you have higher TFR. Similarly, if you have higher concentration of poverty, and because people coming from poor household tend to view children as a means of security when they become old, and of course they also view them as incentive, which I mean they earn and support families in their livelihood. So therefore, it is positively associated based on theory, and we observe that there are certain clusters in districts where, because of higher concentration of poverty, you also have higher concentration of TFR. There is no causal association, of course, but these are just crude associations because these are just descriptive plots. And finally, if you think about family planning access and utilization with TFR, so areas where you have large concentration of no modern family planning use also happen to be areas where you have higher TFR. So these are direct, if you can identify these kinds of map, these are very useful map to tell the local administration and see them. There's something unique which is in these regions, why people are less utilizing these modern contraceptive method. There may be question about demand side, there may be question about supply side factors, so whole sort of things may be working here. But these sort of work, if you can do, will give you policy maker a unique insight, just not the problem, but you also provide the dimension of different problem. Any variable that you're working with, if you can come up with these multiple dimension of this problem, depending upon resources available with policymakers, their commitments, this may be taken care of in terms of decision making and investment to address these problems. Now, this is a kind of a cross tabulation where we were looking at, how this TFR, which is a continuous variable, right, derived measure, varies by the concentration of childlessness. So clearly, if you see, if you just club, make a class interval and see, a group of districts where childlessness happened to be less than 5, 2 to 5, the mean TFR was 3.4. But as the prevalence of childlessness couple in the region or the districts increase, we observe the TFR goes down. So it's very much consistent, kind of pattern that we observed with increasing levels or increasing number of proportion of couples who were had childlessness. We observe the TFR would go down. Similarly, as the indicator of gender preference ratio increased, we observe that level of fertility in those districts also increased. Likewise, as proportion of women who are not using any modern contraceptive method, observe that those district has consistently higher level of fertility, right? As you can see, it's rising over here. And as female education tend to increase, we observe that fertility would fall down drastically. So these kinds of patterns that you can draw based on quantitative work, and then you can model these relationships, right, using spatial regression approach. So the first thing what we do was we simply run an OLS, ordinary least square regression method, which is a basic regression model that we can basically use to find out predictor or factors that might explain variability in fertility rate. So these are aggregate statistics, right? We are running these regressions at district level. So we have 640 units or observation data points, and we have observation about all these independent variable in the model. And using that these data points, we can simply run an OLS, linear relationship between our dependent variable and set of independent variables. Here you can see clearly that this beta coefficient is negative and statistically significant at this is significant at highly significant 1% level, right? So which means that, how do we interpret it? So if there is a unit increase in proportion childlessness couple, there is likely to be minus 0.079 units decline in TFR in a given district, right? So which is okay. I mean, this is simple, straightforward. Likewise, if you look at gender preference ratio, these are positively associated with total fertility rate in the districts in India. And if there is a unit increase in gender preference, it will lead to 0.038 unit increase in fertility levels. It is highly significantly associated. Similarly, currently married women who were married below, legal age at marriage were positively and significantly associated with TFR level. So these are very directly and policy amenable indicators available before us and policymakers to seek any decision they want to make. Likewise, I mean, access to contraception is a mandated policy of the government of India, and also within Sustainable Development Framework. And you clearly see that couples or women who do not practice modern contraceptive, if their proportion is high, so then the TFR in those districts is also likely to be high by 0.025 units. Very significant. Fertility is, I mean, female literacy is a very significant variable. We always, in any policy framework, in any deliberation, in scientific community, and also in policy circles, female education is the key for most of the things. And even for, if you want to bring down fertility, the best thing is to educate women. And we see that, if you increase female literacy by 1 unit, you can bring down fertility by 0.023 units, right? So that is the sort of impact it will have on fertility levels. Now, this is a simple OLS, and this is nothing about spatial, but now we want to know if you include space, how the results are going to change. So we do this two-stage SLS regression, two-stage least square regression, because of the problem of endogeneity. We don't know whether childlessness happens first or fertility happens first. So when there is a bicausality problem, endogeneity problem, we want to check this problem. So one of the ways is to use 2SLS method, which was run. The results are here, and the results are very consistent. But still, it doesn't solve the problem of how do we include the spatial structures. So once you include through the spatial error regression model, you allow for the role of space into this regression, then you see how these results change, right? As soon as you add a spatial weights to the regression and you run the spatial error regression, what happens? The values, the actual impact of childlessness on fertility goes down by almost half, but yet remains statistically significant. Right. So once you account for spatial heterogeneity into this regression model, we observe that of course, there is an attenuation in the effect, but they remain consistently and strong, right? Wherein childlessness still is a strong variable to predict fertility differential across districts in the country. And likewise, we also see for some of the other variables, sometimes the significance of the value is lost. For example, here, once you count for space and simultaneity, the role of gender preference is completely disappears. Whereas we find that child marriage is still very significant, no contraception is still significant, female education remains to be significant. And here we have two-stage, so this is simple spatial regression, right? And if you add simultaneity with spatial regression, which is a final model, we observe that there is some improvement as far as childlessness is concerned. And this gender preference is now finally significant and positively associated with fertility patterns. So these are some of the changes that we observe, but these results are now very adjusted for simultaneity problem, and also because of the spatial structure problem. So this is the final result of the study, which clearly shows that no modern contraception, proportional scheduled caste scheduled tribe population, where you have higher gender preference ratio and where you have higher childlessness. These are the major significant predictor of fertility differentials in the country. So I think I would like to stop here, and I would like to have your reflections about anything if you want to ask or you want to discuss. Thank you.
Any question, please? Anyone, don't hesitate.
I saw the previous presentation was far more technical, and many of your questions were, I don't know the background of the audience actually. So maybe anybody from social sciences, or otherwise also, I mean, please feel free to talk, and if you have any issues, please feel free
Dipanshu?
to give the punch. Yeah.
Majid?
Good afternoon, sir.
Yeah, Priyanka, any question?
Yeah, sir, no question, sir. It was a very informative session, and I had quite a lot to learn from this, as I'm a PhD scholar as well, and my domain is humanities, so I'm doing with social sciences. and it helped clear my quite a lot of hurdles and lot how I was thinking about going about my thesis. So it was a very informative session altogether, sir. Thank you so much, sir.
Majid.
Yeah, good afternoon, sir. It was a very wonderful and enlightening presentation. We could learn so many things. But being from Jammu Kashmir, I believe I have seen all your slides. So that was a blank or gap area
Yeah.
all along your slides, sir. So could we use interpolation techniques to say for infant mortality rate, for example, or some other parameters that were blank in those areas, or keeping in view the sensitivity of this health related data, it is better to leave it blank, or else can we use interpolation techniques?
Thank you so much, Majid ji, for your question. So, if you look at the first study, I think that was the, I mean, we were also very much amateur with these methods and technology then, and we were not very much, we had very limited expertise with this tool. So, therefore, then we could not estimate this value for Jammu and Kashmir, and therefore, we always put that disclaimer, it doesn't represent the exact boundaries of the country. But in the second study, if you see that we have some estimation for part of Jammu and Kashmir, and therefore we did estimate for regions in the Jammu districts in the Jammu and Kashmir where the census 2011 data collection was held, right? So it is always problematic, as you said, for health variables if you have to make some estimations. And there are two things. One is to do a statistical estimation, right? Second thing is how representative or how robust it is to guide policy decision on the ground, right? So if we are able to, for example, this is based on secondary data which is collected through national family health surveys, which are done every 5 years in the country. So based on those households where this information was collected, we can make these estimations. But where this information or surveys has not been done, probably it is not ethically correct to extrapolate and say that that certain behavior prevails where we have never been on the ground. So therefore, demographers tend to, or special epidemiologists tend to not go into places where there was no information collected on the ground, and hence probably it may not be ethically correct to estimate or extrapolate what may happen. If there was some, as far as population projection goes, you are making estimation for the state as a whole. You are using the past trend, past fertility trends, mortality trends, and migration trends, and use them to project it for future for the state as a whole, which is fine. But if you are going district wise, if you are going region wise, and if you don't have information for some district or some reasons, then it is better not to do these extrapolations. Reason being, if suppose there is something uniqueness in those areas, and we don't have any idea exactly based on empirical data, then we may be making certain proclamation which may not be right. And hence for those areas, probably it is better to say that because of the paucity of data, we could not make any estimation, and therefore that is a limitation of the data and of the study.
Thank you, sir.
Sir, one of the student is asking ki, how can we correlate the secondary data with the primary data? How to attach those secondary data sets with your geospatial files?
Well, again, see, depend primary data, what is the major objective of your study? If you are collecting primary data, but it is a secondary data, for example, agar aap, you are working at a village level, or if you're working in city and urban ward level, you have collected some, for example, agar aap main aapse baat karu, vaccination hesitancy ko lekar ke, there was a huge concern before a number of states in India and outside also, ki how to decrease or address the problem of COVID vaccination hesitancy. So if you are using some information based on your primary data from the field, and if you can use some secondary data at village level or at urban ward level, for example, health infrastructure in certain villages or in certain urban wards, if suppose you have good funding, problem is that you should have a good funding to do this kind of work. If you have surveyed some 25 village or some 25 wards, because for doing this quantitative analysis you need some minimum sample size as well. So suppose if you have done at least 25 or 30 villages or urban wards, and you have collected individual level information about hesitancy or lack of trust in the health systems, or some prior not a very good experiences of the health systems. This is collected at the individual level. And if you have at the aggregate level, village level or urban ward level, certain health infrastructure information, or maybe healthcare expenditure at the village level, or healthcare expenditure at the urban ward level, so then you can cross classify and see whether certain districts where hesitancy is high because health infrastructure is not very good, or people have limited trust in these health systems, or because healthcare expenditure is, you can quantify absolute kitna inka budget tha, what proportion of that budget they have spent. Because in government system, problem is many times that even if you get the budget, you're not able to spend it out, and therefore there is no point in getting allocation if nothing is rolled out on the ground. So these are some of the things that you can do, and it's really very good kind of work. If for PhD or any project you want to do, you are doing primary data collections, you can of course take GPS. I mean, just let me tell you one of the example, a project we were recently doing in UP in Jaunpur district, where we were looking at from family planning uptake of females, and we were doing some field experiment in the ground. So what we did was, when we went on the ground, we collected a lot of information. Also, we collected GPS location of each and every households. And now what we can do, we can look at their fertility behavior, we can look at their health attitudes, health information. So that is available on GPS points, so you can plot them, and then you can cross correlate with the distance from health CHC, PHC, in terms of connectivity information. So a lot of things you can correlate with if you have these kinds of information. Agar aap primary survey kar rahe hain, you can of course do a lot of GPS and a lot of these information, health information, behavioral information, and that you can superimpose with the infrastructure in the given community, the health information available in the community, connectivity, the socioeconomic status as a whole in the community. So a lot of these kind of things that you can use from secondary data, you can plot it as a layer, and then primary data, the data that you collect, and then you can look at, maybe you can make some univariate Lisa maps, bivariate Lisa map. You can also do some Moran's eye, these sort of things you can do, and find out if there is any characteristic difference in your primary outcomes and the secondary information. So it is, see, these are all very much fascinating. At the same time, the more time you spend with doing trial and error, you can come out with a lot of interesting findings. So I hope it helps.
Sir, there is another question. Sorry for
No,
taking
no, no.
your
I'm so
question.
happy that people are reflecting. Yeah, please.
Yeah. Sir, one of the schooler is doing her PhD in malaria using geospatial technology. So what the expert suggested her that whatever findings that she has generated, she has calculated the risk donation at a Jaipur ward level, which are the wards at a higher risk, where she has taken the primary data, where she has taken the land use, land cover, then NDVI, then water layers, as well as she has taken the socio-economic layers like population density, sex ratio, household labors, and then she concluded that these are the zones or the wards which are having at a higher risk. But on the other hand, the evaluator said that this is already known that the population density and whatever, if there is a slum, so how will justify that findings? Because that was a finding that created at last, and he said it's known, but the research is you have to prove it, and we have proven
Exactly.
it. So how to defend it, sir? What, that is my question.
So, see, we all know that there are a lot of things that we expect them to behave in a certain way. Research has number of motivations. One of the motivation is to validate, revalidate, re-question, challenge these findings, right? So if you know that if you have if you have certain kind of population densities, of course the problem of health will be there, right? So no matter whatever outcome you take, चाहे वो malaria का आप लें, चाहे COVID का लें, we always know that demography has a role to play, and this needs to be accounted for whenever you are making policy and program. So see, there are many examiners with various motivation ask questions, but the final thing is, research is always about whatever has been established in the past. We always go back and check if it is still relevant, or has there something changed or not. So many times there are a lot of research which come with finding which is so called null finding, है ना? Ki suppose if I want to say education influence fertility, my result is that no, there is no education of, there is no role of education on fertility. So whether this research has any significance or not, most of the people would say, well, because this is not statistically significant, then the study is, hopeless. There is nothing new about the study. I mean, why do I care of a study where the finding is null? But fact of the matter is, even reporting a null finding is also a research, that in certain areas, in certain population, it's not female education, something else might be mattering more, right? So if you want to say that something has been reported and established in the past cannot be done in the future, I'm not sure why that should be a case. Even 50 years later also, we would think about role of socioeconomic factors in population health. If you think, socioeconomic factors are the major basic fundamental causes of health inequality in every society. Indicators are different, meanings are different, but these variables always remain to play the role. Similarly, a lot of null findings where, suppose one example, we were looking at one paper, we were looking at, I think, child nutrition and the role of, most of the study says that child marriage of mother is one of the major significant determinants of undernutrition in the country, right? We had a unique data where we had information about mother's age at marriage and father's age at marriage as well. And when you put father's age at marriage into your model with mother's age at marriage, then you know what happens. Significance of mother age at marriage also vanishes, right? So basically, what does it tell? It tells that age at marriage of parent has no role on child nutrition if you account for father's age at marriage as well. So what is the main finding? The finding is that age at marriage has no association with child nutrition. Now, a lot of editors, a lot of reviewers would say, well, then why we should worry about them, and what is the big deal? Paper is rejected. But you think about from other perspective, that if child marriage is not working, it is very interesting why child marriage is not working. What else is working? Earlier, what was happening, that child marriage was probably correlated with some other thing that was in some sense exaggerating the impact of child marriage. अब जब आपने फादर की मैरिज को इंक्लूड किया मॉडल में, देन मदर के एजेड मैरिज का रोल कम हो गया. So कहने का मतलब, the nutshell, what I want to conclude is that null finding also are very meaningful in scientific research. Likewise, in the past, if certain thing has been done and proven, why cannot we go forward 5 year, 10 year to revalidate it? I mean, you know about the very famous study of ecological fallacy. 1950 में एक बहुत फेमस पेपर लिखा गया था, जिसका मेन कॉन्सेप्ट यही था कि इंडिविजुअल बिहेवियर्स को अगर आप एग्रीगेट लेवल के साथ क्रॉस एसोसिएशन बनाओगे तो वो गलत होता है, राइट? Ecological fallacy, these have become classical studies, and a lot of people talk about it, teach it, that we should be always aware about ecological fallacies. Do not make association between individual behavior with, if you have to draw association, always draw association at the same unit, right? Individual, aggregate. It's very problematic many times to make these kinds of association, right? So इसमें बहुत सारे, there are a lot of views that people have. There is no a final view, but my view is always that it is always good to go and recheck, revalidate. You want to discard it if the data allows you to do it, right? Even null finding are very valuable, and a lot of good papers with null finding are also accepted for publications.
So there is another question from Sugandha Singh. She is saying how population geography can be integrated with cultural phenomenon like music and dance of particular region, and what can be the probable options of mapping it.
Well, it's very interesting. आज के दौर में आप देखें, particularly in COVID-19, we are all restricted in our walls most of the times, and now we realize that how entertainment is important. How cinema halls are important, how going to other places outside is important. So in population geography, of course, you can think about cultural geography, and you can think about different sort of musics in different areas in the country. Our India is very varied and very diverse. So what you can do is you can look at different kinds of music, and अगर आप health के साथ, population के साथ और music को join करना चाहें तो बहुत अच्छा है. So for example, when people have a lot of, because of social isolation, mostly, we are all very much stressed out. Many times we feel low, many times we may have anxieties, many times we may be depressed at times, we don't know. So what gives us solace in those circumstances? I think music has a huge role to play. Music and sports are two things that are really good. for us to release our energy and feel joy and get away with isolation things, right? So as a population geographer, health geographer, what you can do is basically you can look at the popular choices of music in different areas, what kind of music people really love, and maybe if you are doing, you can do quantitative, you can also do qualitative. अगर आप simple qualitative करना चाहें तो आप there was a recently a village in I think Nagaland which has been recognized by UNESCO because it is a town where everybody do whistling. It is a whistling town, right? Our northeastern part of India is very unique in various custom and tradition, other part too. So कहने का मतलब ये है कि if you want to do some quantitative work, you can, for example, have different festivals. You can take different festivals and look at people behaviors, people, if you're looking at mental health and festivals, you can do a lot of interesting studies. And in India, we have a lot of festivals of different religions and cultures. So I think you can write an email to me. I can send you some literature more about, how culture is so significant for the whole idea of festival is what? The whole idea of festival is two things. First, to celebrate humanity as a group, right? And second is to shed all the stress, all the anxieties, and enjoy yourself in the time where you live, right? So therefore festivals, we all know that how festivals have changed last 10 15 years because of technologies. Sometimes technology may not be very good because personal interaction, personal touch, human touch is also very valuable, right? So if you need some more inputs, you can always write to me. I can share my email ID and I can share some literature with you.
Sure, sir. In the chat box, if possible.
Yeah, I've done. Yeah.
So all the participants, because it has been already won, and we have taken a lot of time from sir, and now it's a time to move on. And
Okay.
from behalf of Center for Climate Change and Water Research, Suresh Gyan, Bihar University, Jaipur, Rajasthan, I would like to give a very thankful greetings to Professor Dr. Praveen Kumar Patak, sir, that from his busy schedule, he has enlightened us with the application of geospatial technology with health and its applications, and introduction of a new software, Geoda, if I pronounce it correct. And we will like to have some workshops related to geodata, sir. If you agree at any point of day, if your timetable allows, then this participants will be very benefited with this software. And we too, as a teacher, because we have never interacted with the interface, the kind of data that has to be created, and the what kind of map, and finally we'll be getting it. And altogether, this is a very refreshing topic with knowledge. And we are very fortunate that during this negativity environment roaming around Omicron, COVID-19, again, third wave, we are able to obtain scientific knowledge with one of the best scientists of India working in the field of health, GIS. Thanks a lot, sir. And we hope that in near future also you will be blessing our center or university.
It's
Thanks.
always a pleasure, Dr. Surajji, and thank you so much. I wish you all a very healthy and safe life going forward. Thank you so much.
Thank you. Thank you, sir.
Thank you, sir.
Thank you, sir. And we'll meet at 2 o'clock again. And from 2 to 5, you will be having your practicals from today onwards. So it is requested to all the participants that whoever is attending the session in the second half is supposed to have a laptop with the pre-installed software, that is QGIS. If anybody has any question, he can ask me. It is free of cost. You just type QGIS and download to your system. In case you are finding any difficulty, we'll be helping you out in the second half. So we'll be meeting again at 2 o'clock with the same link. Till then, have a safe lunch. Okay, Majid will be meeting at 2.
Right, sir. Right, sir.
Thank you. Thank you.